last summit. But I like to give you first a short introduction into where we are and what's actually the place here. The story starts... Oh, I don't need this one. Can you switch to the video before? The story starts 4.5 billion years ago. There was a bottle of star soda, so not a cola, but a star soda, which was on a navigation instrument of a space station which was traveling to space. But actually, because of the star soda was falling, it was traveling to time and crashed in the planet Earth 4.5 billion years ago. This space station will be built somewhere soon, but this place here is a place for future archaeology. So what we're trying here to find out what the future will look like. And therefore we have the space here where we bring together a lot of materials or things we think there are parts of this crashed space station, which crashed 4.5 billion years ago on this place called, now it is called Berlin. There was no Berlin 4.5 billion years ago, but now it is. And there are also some parts of the space station, maybe you have some already seen, like the antenna of the space station. It's in the middle, a big antenna. A lot of people refer to it as a TV tower, but maybe some of you heard of TV. You don't need a tower for a TV, that's not needed, but it's a nice antenna for a space station. If you want to know more about the space station, you can read and look at the schematics over there. It's a nice piece of future archaeology to study. And how we do it at the moment is we try to bring together knowledge which is available on the planet and dig through it and find out what is future-proof, what is future-compatible. And that's also why the Matrix Summit is here, because we want to find out, and I think a lot of you have kind of questions into that direction, is Matrix future compatible, and how can it be future compatible? And to find that out and to exchange the know-how you have about it and others have about it, we created the summit to bring together the best matrix expert on this planet, on this space station, to find out how can we use matrix in future. And now I'm coming back to an ancient technology. It's called Zettel in German. And I have some notes made on it. One is about the flexible schedule. So we will have some talks. Steven, can you now fade into my laptop screen? So we have prepared the schedule. We have two main areas here. One is the main stage, and the main stage we can record and we can stream the talks which will happen here. And we have the backstage, which is over there. We cannot record that. I was trying to figure out who wants to be recorded and who doesn't want to be recorded or streamed. I was not really successful with it, I think. So all of the talks on the right side, they can't be recorded. And if there is someone who will give some of the talks there, but he really wants to get it recorded, please hand up now. Some of you want to change the stage. Now is a good possibility to do so. The right stuff. Okay, so then we will leave it like it is. If you change your mind, then please let me know. Next one, COVID test. Yes, there's some COVID going on. There's a test station in case you haven't tested yourself. It's good if you do so we can lower a bit the possibility of getting infected. The chance that some of you already have COVID is really high, because we are something like 100 people and coming from different places, and at the moment in Germany is a high possibility that people have COVID. So please test yourself, and if you find out, then please leave the station and go, or wear a mask at least, and join the stream.
The test station is outside the main door.
Oh yeah, thank you. Then we have an important topic of Weltfrieden. I asked someone earlier on to write a card for me, and I will discover to say something about it maybe later. Seabase, we will have some tours this evening. So in the evening we can get a tour to the whole station, and people will tell you a bit more also what the areas are about, how we use the shared infrastructure to discover future. Then there is some interviews will be made. There's a sound studio downstairs, and Christian want to make some interviews with you for the Matrix Salon. So in case you like to have a nice chat with him, or also together with others about who you are and what you do with Matrix and why, or whatever topic, just go to Christian and find a time to schedule an interview. Recordings of the, so if you do some photographs here, please respect that all the people which you photograph maybe don't want to be on that, so ask everyone who's potentially on the photo. Also, if someone a bit on the side, please tell them they are not in the picture, or ask them. There's very special attention to do you want to be on the photo and what will happen to the photo. Where's the photo published here? It's an important etiquette on this place. It should be also on other places, but here it is important. Next one, drinks. We have some drinks, like we have coffee, we have tea. We have a lot of cold drinks, which will be paid by our sponsors. So I asked a couple of companies, or also a couple of individuals, to put a bit more money in the pot, that we don't need to pay for drinks and for food and something like that. And I want to mention our sponsors here. So there is Actor, which is, we will hear later about it. It's an organization platform for activism. Ben will talk about it, and if you have questions about Actor, then ask him. Then we have Ansible. Who have heard about Ansible? Okay, yeah. There was the Ansible Community Day on Wednesday, and Carol over there and Greg heard, oh, there's the Matrix Summit, and Ansible is doing a lot with Matrix, so they decided to sponsor us, and thank you for that. And then there's Element. Maybe you have heard of it. It's an English company. They have something to do with Matrix. They created a client. They created enterprise backends. They run a lot of experiments and all that. So I think you have heard of it if you are familiar with the Matrix ecosystem. Then there's Family. Is there someone from Family already here? There will be people from Family come. So Family is a German company. They built technology for the healthcare sector based on Matrix. And then there's Matrix. So Matrix, the foundation. So Matrix Foundation is organizing a lot of stuff, and also got a new level this year and in organization, and also they sponsored that event. And then there's Nordec. Nordec is a little company here in Germany which has a lot to do with Matrix, and a lot from the Matrix team is here. So hands up, who all from Nordec is here? You see a lot of, and there are experts in Matrix and especially widgets. Thank you for sponsoring. Thank you to all of the sponsors for the drinks and the food and the pizza we will have later. Thank you very much. Yeah. This afternoon we will have some pizza and some music, and you can chill here, and we will have some networking event. So you feel free to stay here after the conference. I think the pizza will arrive at something like 6:30. And tomorrow we even plan to do a bit more music. There will be a small live act of the coffee bots, and then there will be some lounge music played by Harlings. What's your DJ name? F. You will find out tomorrow evening. Just listen. Okay, the drinks and the program. Oh, the empty card. It was a bit mixed. That's okay. I don't need it anymore. About the recordings and the streaming. Last year, people asked me, can you do recording here? Can you do streaming here? And I said, no, I don't want to do it for a couple of reasons. One was I want to have the intimacy of that people come here together on a summit and meet, and also maybe on some of the topics, here's a good possibility to have a controversial discussion and ask someone, hey, why have you do it that way and not the other way, or how can we do it? And if the discussion gets controversial, I don't want that people get blocked in their head to stop this discussion because the whole audience out there is listening, or it will be stored in the internet forever. But also there were people who said, yeah, but we want to participate in the knowledge transfer and we can't come here. So I said, okay, this year we try a compromise. So I asked the speakers, do you want to be recorded or streamed or both? So we will record all of the talks, but if we publish it or not, you can decide as a speaker afterwards, and we will not publish the Q&A discussions after it. So there's also no need to wait for a microphone. If you feel you want to ask something, then just try it a bit more like a normal discussion and not like a staged environment here, like someone is standing in front of you on a stage or something like that. That's also why we don't use the stage. The stage is for the VIP area. So if you want to be VIP, go into the VIP area, then you are a VIP. Any question regarding this? Okay, then merchandising. So we managed to do another implementation of the MSC 2997, which is there should be, there's a MSC for its shirt. Is someone wearing it? No. Okay, so some of you ordered these personalized shirts. Please pick them up. That's very important because they have your matrix ID on it. Then we have the conference shirts. Please also pick them up if you have ordered them. I ordered some spare shirts, so if you haven't ordered some in advance, you maybe can get one.
Maybe.
And we also, so this is the MSC 2997 front end, and this is the back end implementation. And then we also have some Matrix pure shirts and hoodies. So if you like to pick them up and don't want to order them online, you also can buy them here. That's about the merch. Yeah. The normal Matrix hoodie. Oh, yeah. Thank you, Kim. So now about you. How's our timing?
20 past.
20 past, this is good. Let's figure out about a bit about who you are, or let's start with where are you coming from? Who's coming from Berlin? Who's coming from Germany? Okay, that's more than half of the people here. Who's coming from Europe but not from Germany? Okay. And who's coming from planet Earth but not from Europe? Okay. Where are you from? Colombia. Okay. That was big applause for you for the long journey. I think it was also last year the person from longest distance from Colombia. Greetings here to Jose.
And he was the first to arrive.
Hmm?
Jose was the first to arrive.
Oh, yeah. Okay. And who of you is working as a non-technical person? Okay, okay. And who of these people has nothing to do with Matrix? Okay, okay. And who of so the other people are mainly doing technical stuff. Who of you are technicians who is the main focus on their daily work Matrix? Oh, okay. No, I'm running out of questions. Is there some question someone of you want to ask to the audience?
Who runs their own home server?
And who runs their own non-SunOps home servers? All right. Another question from the audience to the audience?
Who will dance at the DJ tomorrow?
Who what?
Who will dance when DJing tomorrow?
We will see, we will see. The DJ!
Question, who runs his own sliding sync server?
Good question.
And last chance. Last question. Okay, who will program a matrix bot which is sending messages from a room to that bottle display? I will ask this at the end of the conference again. Okay, so I think this was the introduction to the conference. I hope we have a nice time here. In case you have any question, then ask some of the organizers or of the Seabase people. Please raise your hand if you feel yourself as part of the organization or the Seabase. Hands up. Thank you very much. Okay, ask these people if there's anything. And if there's something going wrong or not optimal, just let us know. Maybe we can fix it, or at least we can make a story out of it. Story out of it. We will start with the first talk will not be Matthew talking about Matrix 2.0 because he is still in the plane. So we will switch the talks now, and we'll switch between the Polychat talk and the Matrix 2.0 talk. And we hope that Matthew will arrive in time that before lunch break we can listen to that. Lunch break. If you're hungry, please go over there, eat the brunch. It will be there the whole day. And as I said, in the evening we will order a big pizza delivery. Okay, that's it.
Okay.
Thank you very much.
Boing.
Du hattest gesagt, jeder wird live aufgenommen, aber wenn auch jeder live gestreamt?
Nee, nur die wollen.
Kriege ich Assistance mit dem Anschluss?
Ja.
Bitte?
Nadine, möchtest du auch gestreamt werden?
Ja, gerne.
Wo ist denn den Stream zu sehen? Auf dem Matrix.org YouTube-Kanal?
Auf dem Matrix.org YouTube-Kanal.
Warte mal, wie kriege ich das hin, dass die...
Wann macht die Bar auf? Sobald jemand sich mit einem Bar-Bot-Lizenz dahinter stellt? Das heißt, wenn ich hier nicht mehr stehe, gehe ich da drüben hin.
So, ich muss hier machen auf Präsentation. Präsentation. Und jetzt? Kann ich den hier irgendwo hinschieben? Nee.
Hat er das zweite Display erkannt?
Hat er das zweite Display erkannt? Schreibtisch Displays. Eigentlich doch ja, oder?
Ja, sieht gut aus.
Anordnen. Display ausrichten.
Steven, kriegst du ein Signal?
Anordnen. Ich habe ein Déjà-vu.
Ja.
Mal neu starten.
Nö, oder?
Hier irgendwas klicken. Klick du mal. Eben ist was passiert. Irgendwas ging, ne?
Da geht doch noch was.
Wackelkontakt. Soll man da anordnen?
Können wir den ein bisschen hier sowas machen, dass der von der Auflösung her nicht so hoch ist? Ah, das ist der falsche.
Nee, das ist der. Ist egal, das brauche ich ja nicht. Ich will ja nur die nächsten Screens sehen. Kann ich hier ja. Kann ich die Präse auf deinen Laptop schieben und es einfach von deinem machen? Achso, du kannst Keynote nicht laufen lassen, ne? Kennt jemand einen Witz?
Schönen guten Morgen, ich will auch mal im Bild sein.
Ja, schön.
Was hatte ich heute Morgen?
Hey Jan, du kannst den Twin-Room grüßen.
Ich kann den Twim-Room grüßen. Wo ist denn der Twim-Room da in der Kamera? Hallo Twim.
Seht ihr den zweiten Bildschirm hier bei den Einstellungen?
Na,
Ja.
eigentlich hier, ja. Das müsste er
Ja, dann mach
sein.
doch mal fertig.
Okay. Nee.
Dann würde ich vorschlagen.
Have you switched it on, off and on again?
Ja, und wieder den zweiten Bildschirm, da ist er.
Ja, da ist er. Anordnen. Da ist er nicht.
Und ich hol mal einen anderen Adapter.
Dankeschön.
Ah ja, Wi-Fi-Passwort. Kann ich mal
Kann sich
hier.
nur noch um Stunden handeln.
Ah Mist, da ist auch eine Kamera. Hier, Wi-Fi-Passwort. Ja.
Tanzen bitte.
Hier in der Seabase tanzen wir unsere Wi-Fi-Passwords.
So, jetzt hier wieder Bildschirm. Fertig. Anordnen.
There is something.
Sehr geil. Im Zweifelsfall ist es dann immer.
Wenn ihr in den hinteren Raum geht, wir haben nicht genügend Stühle für vorne und hinten, zumindest haben wir das gedacht. Nehmt euch einfach einen Stuhl von hier, dann if you want to sit in the backstage area and there's not a chair, just grab a chair from here and bring it over there. And if there's empty chairs and there is too much people here, then please bring them back. We don't know how popular the talks will be. So,
How do I go back?
and now, are you ready?
Almost.
Almost. So, dear crowd, please give a warm welcome to Nadine. She will tell us today about why Polychat will save the world. Thank you very much.
Yes, hi. Thank you for the introduction. I was going to make a joke about like, hi, I'm Matthew, I'm going to tell you about the state of Matrix, but no, obviously not. I'm just stepping in. I will tell you today about Polychat. I will tell you about What is Polychat? How does it work? Why is it different to other solutions? Why does the world need this? I will hopefully give you some food for thought as well. And then I'm opening up to questions if I have any time left. So first of all, a little bit about me. I'm Nadine. I'm a UX designer. I'm also a Seabase member. I'm also a mom. I like to do yoga. When I go really crazy, I start fermenting vegetables. Why am I telling you this? Why is this important? It is to show you that I have various different interests and not all of them are related to tech. I'm sure you can relate to that. You probably have a similar circle of interests and everything. So maybe the experience I'm just telling you about now is also you can relate to that. So imagine I'm going to my yoga circle. And there's other yoga moms there, and we had a nice relaxing session, and everyone is really loved up. And then we want to connect. We get our phones out, and we realize we can't connect because we can't agree on a certain messenger to use. And I swear you, all the relaxation is gone if you have to start arguing about what messenger to use. So you're all like probably aware of some solutions, like how we can overcome this problem. So you might say, hey, tell them to install Matrix. Forget it. Because installing a different app, learning a new interface, learning a new UX context and concept is not something you will bring a busy yoga mom to do. It's very hard to convince them. And in fact, I can think of a hell lot of concepts of people who just want to solve a problem, and they want to solve it fast, and they don't want to learn more things. So in my particular situation, convincing them to use Matrix is not going to work. So you might say, okay, why don't you use Beeper or Pigeon or something else? Yeah? Also here, this is not a solution because it would only solve my problem. If I use Beeper, I can talk to everyone, but I actually want to bring the group together. So you might say, hey, install some relay bridges. That kind of goes into the direction of what we're going to do, except that I personally can't install relay bridges, and I would need infrastructure, and I would need technical know-how, which I haven't got. So for me and for this particular case, that's also not an option. My option is Polychat. And I'm explaining to you now what Polychat is. So imagine again the situation, my yoga group, everyone wants to connect, everyone gets their phones out. But now we have a solution. We're not going to go, oh no, we can't open a group chat. We're going to open a Polychat. And Polychat works in that way that in a Polychat, everyone can join with whatever messenger they prefer to use. And they can still talk with each other, because what we're doing is we're having relay bots, like within their own messaging systems. Like the users will enter a group chat with the relay bot, and then the relay bot, there is a back end. So this is like, I'm telling you this from a non-techie point of view, so I hope that I'm not making too many mistakes in that. But the way I understand it is that we are having a back-end matrix rooms, and all the relay bots talk with each other in the matrix room. And then they mirror the conversation back into the room with which the user is talking to the relay bot. So from their point of view, they are just in their normal, they use their normal app, they don't have to reinstall anything. They are in a UX context they're used to. And that also means that the screen they're seeing is just as they're normally used to it. So if you see the fine detail, I was really trying to bring out some specifics of the messenger. So just pay attention to the shape of the speech bubbles. So what I was trying to express with that is that everyone sees the screens as they're used to, and they still can communicate. What is particularly about what we are doing to other solutions which are already in the market is, for example, there's a couple of things. I'm doing my things without my cards, so I might have to catch up with my cards. So this is where I want to be. So yeah, just make a point, because I'm referring to this later. One of the unique things we want to do with our solution is that we're meeting the people where they stand. So if someone is using a particular messenger and that's their favorite and that's what they feel comfortable with, they're not going to have to change their messenger. That's one of the main points. Keep that in mind. I'll refer to this later. The other thing is that we want to present all the users equal. So if you see now, we have an additional person joining from the green messaging system. Within the group chat, there will be no Zweiklassengesellschaft. So there will not be a everyone from within my system I can see differently, and everyone who is from a different system is somehow relayed and behind a bot, and they're kind of like those other people. So we're trying to really break those perceptions down. Everyone in the group is the same. It doesn't matter what their original system is they're coming into. This is also really important for a point I want to make later on. And the third thing, which is different with the way we are approaching this, is that if you imagine, again, the yoga group, but then, like, as I said earlier, I'm not only doing yoga, I have other interests. So I'm also a mom, and within this context, I have another group, and I might start another Polychat, and within this context, it's far more important that I identify myself in this group as Miko's mom and not Nadine, and not Nadine the kimchi queen or something. Like, I can use through pseudonymization, by using a pseudonym, which I can, because every group, in every chat I am with a different relay bot, and therefore in every chat I can have a different name. And that's, from a user point of view, that's incredible. That's even better than any of the solutions on the market, because if I normally use WhatsApp, I always have the same screen name, no matter in what chat I'm in. So personally, me, like being a UX designer, I'm very excited about that. Keep it in mind for later, because there's some more beauty coming with this element. So yeah, here I was talking about pseudonymization, because in different groups I can appear with a different identity. So to sum up, I would say Polychat, and one of my talented tech people came up with the slogan, Polychat, we do relay bridges, but properly. And I think through this particular way, how we're doing it, as I said, we can meet users where they stand. All the users are represented equally, and we have the possibility of pseudonymization. Thank you very much. I love that. Right. So now let's have some excursion. Why is that important? I had a really interesting... So usability, clearly, yeah? What we're trying to do is to make this really usable. And the way we're doing it is by actually like giving people the opportunity to stay in their known confines, in their known chats, in their known chat systems. But something happened to me the other day where I think there's actually a different level to it. It's even out of the user's frame of mind usability is a really important aspect. I was on a conference the other day presenting Polychat, and afterwards, sorry, I have to drink a sip. Getting all excited now. And afterwards, some very talented and brainy tech person came up to me and she said, like, yeah, you know, this thing with Polychat, very interesting, but it's nothing new. It's been, relay bots have been around for 20 years, and I really, you know, your presentation was cute, but I really don't understand what's the big hoo-ha. And I was like, okay, I'll take your criticism, tell me more about it. She gave me some really good input. I was happy, but I took it away thinking, nah. And then the next person turns up and goes, oh, tell me about your project. And I told him about the project, and he goes like, wow, this is so great. I'm in the same experience as you. This is the best thing after sliced bread. I want to have it, sign me up. And I'm like, this is weird. How come that the perception of this is so different, like within the same room? And then it dropped, like, der Groschen ist gefallen, the pennies dropped. And it is all about usability. The technology which is around at the moment might be there. I mean, I got excited about Matrix when I figured that this, come back. That Matrix is capable of this
interoperability.
Thank you very much. I was really excited about that, and to find out the technology is really there, and it's just a question of like getting it together and stuff. But really, it is not accessible. And I'm kind of thinking like, if the usability isn't there, then the exposure isn't there, then the impact isn't there. And I think that's so often, but this is another talk altogether, that's so often the case for open source software. You guys are creating the most amazing stuff, and it's not seen as much as it should be, because very often the usability isn't there. And I know this is a totally different talk, but like this is, you know, food for thought. So for me, in the question of what we are doing differently with Polychat, we're definitely going to have a look at really good usability so that this amazing aspect of Matrix is accessible to the normal user. Interoperability. So, what do I have about that? It's amazing, isn't it, how we have letterboxes at home, and we know that the mail is going to come to this letterbox, no matter whether the postman brings it or the guy from PIN AG. We know we're going to receive parcels, no matter whether they come from UPS or FedEx, or who else brings parcels, DHL. Yeah, so that's totally normal. That's our norm. We receive phone calls, and we don't even think that there might be a difference, no matter whether the person who calls us is from Vodafone or has a O2 contract or a telecom or anything. And I mean, you could even take it as far as thinking like there aren't streets just for Volkswagen and other streets for Mercedes and again other streets for 2CVs or something. This is just obscene. Why do we accept this with messengers? I mean, this is so. Who made us accept this? This is just bizarre. And I think, and I hope that with Polychat and with like bringing those relay bridges to the world, we can really open up people's minds and raise their expectations and almost like reclaim the freedom of communication which they ought to be having, in my humble mind. So you might say, like, threat not, it's all going to come. The Digital Market Act is on our doorsteps. I had a very, well, not a deep dive, but I had a couple of days reading about the Digital Market Act and trying to get my head around, like, what this means and how this will affect our project. And I understood that there are big gatekeepers who earn a certain amount of money, have a certain amount of users. And I also think there is only going to be WhatsApp and Facebook Messenger, who is actually defined as a gatekeeper. And I learned that these guys have to make themselves interoperable, but only if they're addressed by smaller competitors, saying, hey, we want to communicate with people in your network. And I've also heard that Signal and Threema, who would be in the position to ask WhatsApp to open up, have already announced that they're not going to do it. Why? Because they understood that their users are partially with their systems because they don't want their personal data to go with Meta. They don't want to have their personal data connected. So again, what good is a Digital Market Act? I know there's far more, but in the small Article 7 where they're talking about interoperability of chat systems, what good is it if people are not gonna make use of their right to get this interoperability because of their fear of their personal data being passed out? And then another load of pens fell down. Pens fell down? Can someone translate for me, der Groschen ist gefallen, please? Understand. The pennies dropped. Thank you very much. So another load of pennies dropped. Because I understood that the way we are using the relay bots, and with this pseudonymity, Polychat is solving this problem. Because with Polychat, you are in a room with your personal relay bot, and think about him like a concierge in a hotel, or your personal mailman, and you can send him out into the other, into the back-end matrix group chat. And what he will pass on is the conversation. Yes, the conversation gets mirrored, but only the identity you have given yourself within this chat is going. So you're not going to pass on your personal detail, you pass on your pseudonym. And I really love when I'm very excited about a UX issue because I think it's really cool for the user. And then I realize, yeah, but there's also a technical impact in that, there's a political impact in that, and there's actually an impact of how we can make this to really work on many levels. So will Polychat save the world? Come on, it's a piece of software. It's not going to save the world. But in my hoping, we will make it a little bit better because we show what's there, what's possible. And I think it's very often the value of small projects who are outcome-driven, who are not commerce-driven, a lot of open source, a lot of people like us sitting here thinking about like, how can we make this better? We're showing what's possible, we're pushing boundaries, we're showing, yeah, we're bringing ideas out of the open, we're making them work. So we make the world a little bit better, step by step. And before I close, I will bring a quote to you, which I saw in a documentary the other day. There was an architect was interviewed, and he built a Müllverbrennungsanlage in Copenhagen. So a room, a house in the middle of town where energy is created by burning trash. And the architecture is really beautiful, and there's grass on the roof, and you can go there to picnic. And the guy gets interviews, and they were saying, like, why did you think of something like that? Why a trash dump in the middle of town? And he says, because it's possible. Because the visions we realize today become the normality of the future generations. And I hope and think that that's why we're all here. And that's why we're making the world a little bit better step by step. Thank you. And I have time for questions. The first one should be how to make this work.
Kannst du mal
Thanks for a very nice talk. I'm curious about what specifically is the state of Polychat today? How far have you come, and what are the challenges that are?
Polychat is, I'm proud to announce that we're funded by the Prototype Fund. And we've been thinking about this for the last 2 years, I would say. And, but we now have some funding since the beginning of September. And I have a great team with me. There's Andre, I see, there is Jan, I see, there is Sake somewhere here. So I have a lot of very talented people working on this. I think the technological state at the moment is that we have all the matrix servers in place, but we know what we're doing. and quite frankly, you know, we put on this, we still have to prove the concept, I think, particularly when it comes to the interface. I think that because we're basically trying to hack ourselves in the interface of a different software, of an app we can't interfere with. So we'll have to be really tricky and smart, and I don't know where we're getting. But I will have another presentation at the end of February, the closing for the Prototype Fund, and that's when I will present like how far we got.
And if you want to follow the...
Oh, yes. Sorry.
And you can check on GitHub Polychat project.
Yeah. Are you planning to charge users for this product? Like, is it going to be a price thing?
To be honest, my first vision is to have this running. But of course, I want to maintain the thing. So we have some concepts of how monetization could work. And what we kind of like at the moment is a sort of idea how we talked yesterday about, I always forget that you're the guy with gaming, right?
Yeah.
Not diaspora, but...
Well, commune, that project, or the...
Sorry? No, the chat system you're using.
Oh, Discord. Yeah,
Discord,
yeah.
thank you. I always forget Discord. What I like about Discord is that the finance, like it's finance, or like within the group you vote, and then and I kind of like the idea that not a person is financing it, but like a group.
Yeah.
So I would like to, but it's sort of it's not thought through, but I would like to have a system where, like within the group, we can maybe have a possibility for a micro payment, and then the group together would pay something like, I don't know, €1 a month or so, and with that we could sort of maintain the infrastructure. So cool. I think the first step is really that it's a proof of concept. And if we can maintain the infrastructure at some point, great. If we can maintain ourselves at some point, even better.
Nice, thank you.
Slow process.
There was another question. I assume you need to break an end-to-end encryption for this product, or how does that work? Or will it be possible with MLS or some future technology to have full end-to-end encryption?
Someone give this guy a microphone, please.
Oh, I have. No, it's right. In the first place, we will break the end-to-end encryption. But with MLS, there is a possibility to use for some of the services they do. The project itself is like a plan B in terms of interoperability on the DMA level. So the DMA level is like they try to secure the capitalistic market, that it is not monopolistic, but we try to enable free speech. And maybe it will not be only important for the big players on the market to have something like that, also for the low or small players, and therefore We think it is more important to bring the people together than to bring them in the most secure way together, because if you want to have a really secure messenger solution for your group, then you maybe should stick to some and don't use some bridges. But if it is, you want to talk to people, then this is a good solution. And I think breaking then the encryption is a good price you should pay for that.
Does that answer your question? I think in general as well that a company which is normally, or big companies which normally get their profit from enclosure, like, I mean, messaging systems. I remember I installed Telegram back in the days because of the movable, like the gadgets in it, like the stickers, and the stickers move, and that was great. But really, I think there's not much, from a user point of view, there is not much difference between messaging systems. What you're really buying is the other people. And I think that companies who make their money with the enclosure, they will not open up in a way, well, they probably won't want to open up, and if they do that, they're not going to do it in a way that it's really free and open. So we're trying to make a possibility visible. More questions?
I was wondering, so you mentioned before that you somehow hack it into the other clients. So what is the planned procedure to creating such a Polychat? Will there be a website where I create one and then I can join from different platforms?
To actually create a group?
Room. Yeah. That's
In the first step, in the MVP, we're going to have a website. So you go on the website, you say, create a Polychat. Then the people you invite to speak, they will get whatever contact you have from them. So they either get a message in a particular messaging system, or they get a phone call, I was going to say, a text message. What I think is really important, that they still have the choice to choose choose whatever they want to enter the chat with. They don't need to, you don't make the choice, but the people make the choice. So in the first level, it will go via a website. The midterm vision is that you can start a Polychat from your client. So out of WhatsApp or whatever, instead of opening a group chat, you have a certain telephone number, that is Polychat, and you make a chat with Polychat, and out of this chat you can create a proof chat. And then the whole procedure would be without you even leaving whatever you usually use for chatting.
Okay, nice, thanks.
And the long-term vision of it is that actually you can use existing groups on a network, like a Telegram group or WhatsApp group, and can
turn it into a Polychat
transform it into a Polychat chat that people can switch the messenger without leaving actually the group context.
I'm having a rather untechnical question. Eventually, when you have the system up running, you will connect various users for various chat platforms, and eventually nobody will really know which system the other partner he's chatting with will be using. So how are you going to deal with the declaration of data privacy consent in this setting? Because you will share messages despite your profile being hidden, but in the end you will share information to platforms you don't know.
I had a solution to that. In the RGBs, there are of the particular of the various messengers, there are phrases which, at the first glance, forbid us this. I personally think it's a kind of question of interpretation, because what we're actually doing is that the user has a chat with a service, and so within my original chat, I am with the Polychat relay bridge, and I tell this bot to pass on this into a room. So it's kind of like, it's like I send a courier. Yeah? So it's not really that we're sharing the conversation. I had this thought through. Basically, I know we're kind of on thin ice there, but I'm willing to fight that fight.
Can I jump?
Go for it.
What's your question? What we do with data types when someone is sending, for example, an image and the...
No, it was a non-technical question.
It's basically all about me as a person. I want to use the system, right? And I'm going to expose my data to other chat platforms, which have contracts which I would usually agree to if I would use the native platform. So I theoretically would read them, of course, all the 1,000 pages, and then agree to it.
Yeah,
and now in this setting, I have platforms I may not even know, and I've never read all these contracts.
Yeah, because you don't have a contract with them. You send Polychat to do that for you, and you have to read a contract with Polychat or to deal with them, but Polychat is going to WhatsApp or to whatever, and it's actually not really going there. It has contracts with all the other people, and it just brings in their name the message together on their platform, and then gives it within the contract they have with Polychat back to them. So it's like postbote.
So sorry to understand, was your worry that what you're saying, that your chat content is now legible in other platforms, or is your worry that you somehow are in a contract with someone you haven't signed up with? What's your pain?
That's the latter. So
the latter.
I'm in contact with somebody I don't have any agreement with.
Yeah.
And so on the other way around, the big company I'm not in agreement with, who is processing my data,
no, they don't.
should potentially have a big interest on not receiving my data, because then I could basically, somebody could do them harm legally. And that's just an assumption, of course, but it's a big question. I don't want to stress the matter too much here, but it's...
I think it's a very important question. I think it's a very important question, and we had a lot of brain cells died while we were twisting our minds to find a solution to that. But in our interpretation of what we're doing, you're not passing on crucial information. You're crossing on you're crossing on a crucial chat, but you're not passing on your personal conversations, and you are not in a contract with these other providers. This is kind of how we are running at the moment.
Thank you.
Thank you. There's one more. Thank you, Kim.
You're welcome. Where can I follow your progress in your project?
We have a Mastodon.
Yes, it has 2 posts.
Yeah, I know. Sorry.
And there's an RSS feed on your website which has the Hello World WordPress post.
Yeah. Mea culpa, I know. But theoretically, these are the right...
Is there a matrix chat?
Yes, there's the Matrix Ambassador chat, which is open. You can probably find it. It's the Polychat ambassadors, and that is kind of like a group of people who are really enthusiastic. And once I've get over this whole process of setting up the team, talking to the prototype fund, and getting myself into a decent workflow, I will also announce things on this channel. Okay. But at the moment, I was happy that I set it up, and that's it. Okay. But on the Mastodon, you saw a photo of Kim, right? No, the other picture. Okay, well, that will be the 3rd post then. Right, well, thank you very much for this opportunity to present. I'd love to have some feedback, whenever. I'll be around for the next 3 days, so hit me up with that. Thank you very much.
Okay, now it's a 10-minute break, and then we will start in the backstage with the menu flow talk. And here we will start at 11:30. Ben is talking about Actor.
All right. Menu flow, the Matrix bot codeless builder started 2 minutes ago in the backstage. If you want to see that, please go through there. By the way, there are the toilets on the right. We didn't mention that. So go through there. Maybe grab a chair, because we don't have that many chairs back there.
And now, ladies and gentlemen, get ready in the main hall for the next talk from Ben Kampman. He is talking about activism organizing on Matrix. Hello, Ben!
Hello! Thank you very much for the warm welcome. Also, hello to the stream. We're currently working on setting up a Matrix room so that you can ask questions. I'm not sure that's going to happen before I'm done speaking. Two more slide announcements. The bathrooms are down here, or if you go to the backstage on the right. If you see any symptoms of something that could be COVID, please take a test outside. If you have been here before for a while, let us know so that we can inform the participants. I know it's annoying. I know the nasal swab is super annoying, but I did it this morning as well because, well, better safe than sorry. I don't have 45 minutes. I have about 25 because we all know that after 20 minutes, the attention drops anyways. But there's time for questions and answers later. You can also find me at any time. I'm the guy with that hat and that T-shirt, and there's another guy with another similar hat that he's insisting on not wearing. If you want to talk about Actor and what we do. So first, two things about me. I'm Ben. I'm the co-founder and tech lead of Actor, formerly known also in this space maybe as Effectio, because I presented what we were working on back then already a year ago. I was the Rust developer for New Vector Element and the lead developer for the Matrix Rust SDK until earlier this year. And I've been doing like decentralization in Rust since about 2015. I've been working in the space since 2011. I've been doing some wild decentralization stuff. Maybe you heard of like blockchains is one of them. Only once. But I've also been co-hosting the Rust Fest and Open Tech School and other non-profit learning opportunities, as well as I've been a political organizer for a political party here in Germany, as well as for local grassroots initiatives, and that becomes important later. If you want to know more about me, you can find me at gnuunicorn.org. There's also a way for you to contact me. So we use the term organizing, and I want to take a few moments to talk about what we mean when we say organizing. Because we don't just mean like a spreadsheet or something. We talk about organizing in the socioeconomic, political context, how they talk about this. That means that people come together to usually work towards a specific goal or aim. That can be a neighborhood coming together to create a neighborhood street festival or something like that. It's generally in a social context. So we're talking specifically for the non-professional side. You're not getting paid to do that. You're doing that voluntarily, you join that group voluntarily, or because of social pressure, but generally, let's say it's voluntarily. And that takes place outside of work, where you usually have a lot of other things you also have to take care of, like groceries. That means it's inherently non-hierarchical in the sense that no one has the power over you to make you do things, right? It's peer-to-peer. There's social pressure to some degree, but you could always say no and walk away, and there's no harm done. You're not going to get forced to do stuff. Which also means you have no bosses, but also no project managers, no one who's doing all of that organizing stuff around you to actually make things possible for that to work. And generally, this is how most things in civil society, and specifically grassroots activism, are structured. They come together, people come together, say like, hey, we need to do something about this. They organize protests, and that is generally this sort of thing. So where and how does that happen today? If you are a user of one of the famous messaging apps, it's WhatsApp. Most of the time it's WhatsApp. You might have your family chat as one of these examples, but also like you have a lot of activism or social good causes happening over WhatsApp, where you have a group of people who somewhat share some kind of, I'm sharing one screenshot here of one of the things that then usually goes wrong, and that is like in WhatsApp, you know, like you don't have a history. People join because you're like, hey, they have a car, they can help us. They join in, and it's like, I have no idea what the context is. I don't know. Please, someone catch me up. And there is no project manager. There is no one onboarding you in these kind of scenarios because that is extra work that nobody wants to do. So it usually becomes a problem for these kind of structures. Maybe you're one of the lucky ones and you don't use WhatsApp but Telegram. I'm saying lucky here because the tooling is slightly better. You have at least this differentiation between like channels where there's like a lot of information boosting out into one direction, and you have these more community chat style things. That is very nice. But there you have a similar problem. Like this is my screenshot for a bunch of these groups right now, and you see these counters, right? Like Klimakrise 534. I'm not ever going to read that, right? And that means I'm missing information. I'm not able to catch up. And generally, like as soon as you want to do something that requires a little more structure than just a textual stream that can just go on, like just think of the bake sale that you're supposed to organize for I don't know, some event. And like someone said, oh yeah, they're going to do a chocolate cake. But then 3 messages later, they're like, oh, I can't do a chocolate cake because I don't have chocolate. I'm going to do something else. Someone else joins later and is like, I can do a chocolate cake. You lose track of what's happening, and then you end up with 3 chocolate cakes. That's still not the worst of all scenarios. I think 3 chocolate cakes is great, but you see what I'm getting at. And so usually, what do we do when we need more structures? We set up an Excel sheet, a Trello board, an Asana, a weekend board, a GitHub or Jira project if you're really masochist. Who has done that for like trying to get a group a little more organized like that already? Yeah, and so why do you think it failed? I can tell for like, if you meet anyone who tried to do that, it's going to fail. There's like maybe all over Berlin, a single-digit cases of that has actually worked. But it generally doesn't work, and the reason for that is because of a lot of things that I said earlier above. That is, how is this group actually organizing, and where are these tools? These tools are used in a professional context. Most of the time, they have amazing charts and flow diagrams and waterfall and like Gantt charts that tell you how long it's going to take. That doesn't matter for my bake sale. This is all annoying bullshit that I don't need for my bake sale. And at the end of the day, the ones using and paying for these apps, for these applications, are the companies. And they have other interests than that the people who use them really want to use them, because in doubt they're paying them to use them. And that makes them inherently different from what you need in the other context. This is why so many are stuck with WhatsApp and Telegram and similar systems, because it's at least something they know how to use. And that's exactly what we're building or trying to build at Actor. We're trying to build what we call casual organizing, so all of that organizing that happens on the side where you don't have a managed structure around you. And we're building that on Matrix. And now I want to show you what that looks like. All right. All right. Yes, that looks good. I'll get this away. I'll get this away. And I'll get this away. Oh, no. Why did it disappear? It was there, right? Okay. Let me try to plug this over and on again, as usual. All right, I can resize that so that it works. Does it work? Oh yeah, perfect. Okay. So on the left, you see that doesn't quite work, but we're going to fix it. So this is the mobile emulator, and that's our desktop version. So what you see immediately here is we have this idea of having a social stream-like newsfeed that you can directly see that one most important thing from my organization. So if you are in one of the rooms that has like 180 messages, but one of them is really important because it's, hey, come to that protest on Saturday, you're going to miss that message because you see that 180, you're not opening this. And that's a way for the organization to say, hey, aside from chat and all of that stuff that's going on, here's a low volume, high signal place where that is the most important information. The idea is that you can do that on your way to work Monday morning. You can flip through the most important things of all of the groups that you're working with. We've recently also looked a lot into how do we, we organize all of that in spaces. You should know about spaces if you know about matrix, which is a fairly new but very important way of structuring, hierarchically structuring objects. So we looked a lot at like how we use that, and knowing from how many of these organizations, even grassroots organizations, tend up to make work possible is that they specialize into smaller groups on one side. For example, you have a group and then they do social media, and then that becomes its own group. And most people that don't do social media, they don't care. And so we've looked a lot at how can we make that possible, how can we make that easily accessible, and you can just drill down into whatever depth you want. But if you're only in one depth level, you can easily see your groups, the groups that you're in, and just directly switch there. The most interesting thing, though, I'm going to go to this one, is that we also offer, so this is the same on the mobile version, just going to go into pins. So next to the regular chat that you would expect, we have a few alive objects in a room. So these are things that you can interact with as a user, as a member of that space. For example, pins. A very simple place where you can just see all of that fridge or pin wall-like information. Like, you know, the dog needs medication, but it's like once every 3 months. What is it again? Well, you can just go into the pin, check it or not. Why is it not opening? Oh, wait. And see when is it due, what is that single information. It can be about like where's the car located, where's the garage for, or what is the pin of the garage again. Things that are important in a specific context, but you rarely need all the time. So it's a very simple and easy way to just manage this kind of stuff. The other thing that is very important, especially for social organizing, is events. So this allows you to schedule events, a very simplified calendar, if you will, saying, hey, this is an event that's happening, and you have an easy way of saying, oh yeah, I want to join that. The idea, again, is that probably already exists in like the Telegram group or whatever, but it's hidden somewhere in between all of these other messages. So it's really hard to find for people who are more casually coming in and out. And the idea is that if you look at the news, and you want to drill in deeper down, you can easily do that by doing exactly that. And another thing I want to show you, but don't tell Emil that I show you, because this is a labs feature at the moment, and that's like to-do lists, very simplified to-do lists. Nope, I need the to-do list, where you can just add things. You can say, oh yeah, I bought the milk, and of course, yay, network worked. It updates immediately. No, we still need honey. And I can say, we have prepared that, and I am, is it updating? No, it's not. Give the presentation. It's a demo. It always happens at demos, right? All right, let me get back to the different screens. All right. Okay, that's the mouse. Nope. Nope. Well, almost. Now we're there. Okay, cool. So this is where we're at. We have chat, obviously. I didn't show you, but you can trust me that we do. It has end-to-end encrypted chat like WhatsApp, Telegram, Signal. It's the metrics default, right? But aside from that, we have this new feature, which is called updates, that allows you to have a really quick and easy scroll through for especially larger groups where you have a lot more people that are less strongly connected. We have the pins that allow you to easily pin information that makes it easy to look up, that are important. Very often that is used for, I don't know, the onboarding guide or the checklist for protesters, that kind of stuff. And we have the calendar events all implemented, and all of that in just one app. So how is that different from WhatsApp or Signal or Wecan or any of the other types of boards? Well, you already saw it's meant generally as a quick and easy way to catch up. Our ideal scenario is that aside from the absolute pro users, most people do not use that app that often. Right? This is counterintuitive to almost all other metrics of all companies out there where like eyeballs on the app is the most important thing because they sell you advertising. If we can get you to do the thing as quick as possible, that's better for us. That's what we want. That requires a clean and fresh and modern UI. And in particular, an aspect of thinking of the classic organizing tools, to-do lists and that kind of stuff, in the non-project manager context. What if I don't have a project manager that in doubt will manage all of these great things and connect all of these issues and move all of these things around? We don't want that. We cut them down to the bare minimum wherever we can. I mentioned already before the idea that you have something in chat and maybe that then floats out of the chat into like less noisy spaces so that it makes it easier for people to move back in is highly important way of organizing information in general. The tools generally are the non-business suite tools. The casual organizing generally assumes that all of the stuff we have in the professional context that is really great in the professional context, we definitely want the same for the casual context. But it has this distinct difference that there's no one being paid to do all of the extra load and work around managing that thing. So we want to reduce that as much as we can. Then another thing that makes it different to most of the apps is end-to-end encrypted. That is not yet default on for the tools because like a fully encrypted history is a complicated thing because we need the history of all of the objects to calculate their latest state. So currently spaces when you create them are not end-to-end encrypted. You can switch that on, but it's not on by default. And it's decentralized, obviously, because we're using Matrix. And that is simply all our backend. So you saw the app, but behind that, that's the default synapse. We switched on one MSC, but that is for the purpose field for spaces to figure out which kind of spaces are our type of spaces and which are regular spaces. But that doesn't actually do anything on the server. Yeah, and you can try it yourself. That is something we couldn't say last time when I was here. But it's available in the iOS App Store everywhere but France, and in the Google Play Store for Android. If you want to know the France story, you can ask me about it. You can find the nightly releases as well, especially for all of the desktop versions at docsactor.global. If you don't have a Matrix account yet, which I assume is not the case here, but you might want to invite other people to use it, you can register if from within the app. It's going to ask you for a token, and that would be Matrix Summit with an uppercase M and S 23. That is available until the end of the year. Also for the stream, if you want to use it, you can do that. Then you're using our server, so you get an actor.global address. And we would like to for you to try it out and give us feedback. It's a preview. Are there bugs? Yes. There's an entire GitHub filled with bugs. But especially if you find things that aren't working for you or that are new to you, please let us know. You can either do that on GitHub or you can join the Matrix channels at Foyer or Tech if you want to talk more tech stuff. The Tech channel is literally the one that the entire tech team is using for day-to-day operational stuff as well. So we're discussing all of the technical details if you want to know what we're actually doing. And I am very good on time. That's very good. So I want to say thank you. I'm going to give you the things again. Oh, yeah, we're also hiring. So if you want to do Flutter and Rust development on Matrix stuff, you can go to actor.global. There's the job opportunities on the top. You can see what we're currently doing. If you want to know more about Actor, you can find it. All of that there, including the GitHub Actor Global A3. And you can find me and more about me here. And I'm available for questions. Doing the mic management? Other questions? If there are no questions, I don't have to give you the mic. Okay, you have to pass it to the next person, I guess.
Are there any export features, like for example the calendar, might also be consumed by people on their regular calendar client? And I mean, I assume everything that you said will be somehow inside the Matrix universe.
Yeah.
But yeah, for example, the calendar would be one thing that I would might want to have or assume other people want to have in their regular calendar? And if you do it, how do you do it?
Right. So we don't have an export in the app right now. The idea is that if you have these app installs, we have access, especially on mobile phones, we have the access to your local calendars, right? So we can provide a technical calendar locally. Why don't we just give you an ICS or an iCal feed? Simply because we can't. If that is an end-to-encrypted place that you have events in, on the server side, I can't decipher that, and that's on purpose, right? So we need to do that on the client side, and that is the goal. We're definitely not there yet. It is not yet tightly integrated in that. There's, especially around meeting management and event management, there's a bunch of ideas, like also showing, hey, on that event you already have this in your calendar. So we can tightly integrate on the exact client level. That is the plan, to do that. Which unfortunately means if it's not specifically one that is provided by the system, so for desktop systems, especially for Linux, there's a plethora of potential ways. It's not yet clear how we might going to do that. One way is that we might offer a way to have, I don't know, a Thunderbird extension or something. But we haven't focused on that yet. We're trying to get an app out first, and then if there's demand for it, it's open source, like sort of open source. You can definitely contribute to it. Any other questions? Please pass it on.
Thank you. My question was, so you built this thing with Flutter?
Yes.
And you were using the Rust SDK, right?
Yes.
Did you had any performance hiccups or problems in that terms to manage end-to-end encryption inside your apps?
No. So for that end-to-end encryption stuff, we completely use the Rust SDK. We don't know about hiccups on that. There's the layer in between those two. We're not using UniFFI at the moment because there's no backend for Dart, so we can't port that to Dart. So we have our own self-made thing at the moment. We're currently looking into, or like working on building a Dart backend. That has performance implications, let's say, because of design issues made early on. We are never freeing any objects that we send over the Rust side. That is obviously bad. But so far, end-to-end encryption has not been an issue. That is all running on the Rust side. I am afraid, so we only support mobile and desktop at the moment. I am afraid of looking at the web version, because first off, we have to then put that into WASM, which also means our in-between layer is not going to work the same way. WASM is a lot less efficient in the way that Dart users said, and then Dart itself and Flutter itself on web is just not smooth, let's say. So we have so far put away the web client as a, yeah, we need to look at that for sure. But we might have to rebuild the entire UI. So that's why we're touching it.
Right. Thank you.
Welcome. Any other questions?
Thanks. It seems like you have quite a lot of different custom event types and stuff like this.
Correct.
Have you looked into, considered standardizing some of this? Are you publishing the specifications for them? Do you want people to be interoperable with your custom events, or is that?
Yes. Yeah. So we have, you can find them all in our GitHub on the native core source events. They are fairly much informed by existing standards, like the RFC 8984 for JMP, which is activity stream style events. To describe them, most of the existing decentralized systems, however, always think about a state machine at their end state, like ActivityPub or something tells you like there's this post and there's like these kind of things, not necessarily the entire stream of things. So like some of these things needed to change. They do exist. However, the events you can see there already are a lot more, have a lot more features than we currently have in the UI. And one of the things that's very important to us is that when we bring them into a specification process, that we can be sure they don't change again next half a year. Because once it's out there, it's going to be annoying to change. And we are much more driven by UI and actual users using it and try to inform that back than what the let's say, general metric specification process usually does at the moment. I think a very good example of why we don't want to do that is how the way that polls are now a standard, but like in the UI somewhere hidden in some way, and it's really not clear in some certain edge cases what is supposed to happen. We want to have a lot more clarity before we bring them up to a formal specification, but they're all there, and definitely, yeah, if you are interested in using any of them, building on them, they are pretty clean and easy to understand. Please use them. That's all. And give us feedback. That's the most important thing. Like if you have problems with that. So like one of the things that we have in there is to-do lists and other things. You can have priority, but also a color. You can set specific colors you like yourself. Like a lot of fancier to-do list specification systems like JMP and stuff like that, they have that kind of thing. So this is already in the events, but we have no UI. And we're not sure if we want to keep them because it might be also just too much for UI.
Thanks.
You're welcome. Any other questions? Okay, wait until it's really uncomfortable. I think I did. Thank you very much.
Hey. Whoa. Ladies and gentlemen, Mystic Spiral, give me some signal. Turn down the music. Dear audience, fasten the seatbelts. Now, thanks to Chronicle Services, they helped us to fix the issues with the timeline. And so now imagine we jump 2 hours back in time because one of the speakers, the guy who owns the handle Matthew:\matrix org, has arrived. He fixed his teleportation issues from London and is now here in the main hall of the space station. Get yourself a seat. There are some seats in the first row still available. And listen to his upcoming talk about the Matrix State of the Union, and give him a warm welcome. Hey, Matthew.
Was not a genius. Right. Is this working? Oh, no. Wonderful. Brilliant. Well, hi, everybody. Thanks, Jan, for the introduction and also for letting me talk about Matrix here at the Matrix Community Summit. As I guess you probably know, I'm Matthew. I'm project lead for Matrix and also day job CEO and CTO at Element. And thought it would be useful to try to summarize where things are at right now. So I consider this basically a follow-on from the talk that I gave at FOSDEM, imaginatively called Matrix 2.0, how we made Matrix go boom, which at the time was slightly aspirational. Now it's actually happened, and you may have seen that we shipped a whole bunch of stuff yesterday so that people can actually play with the shiny new Matrix 2.0. Well, not really new features, basically the speed-ups and the improvements of Matrix 2.0. So I'm hoping that people have had a play with Element X and seen what it does. And basically, I wanted to talk you through the process there, what's been going on, a little bit of what's coming up, and also where things are at. Also, I apologize if I look blank when people come up and say, "Hello, Matthew, it's so good to meet you," and I have no idea who you are, because I will know you from your Matrix ID and your avatar, but probably not your real name, and definitely not your corporeal, physical human form. So apologies if I look blank. Right. Let's hope. No, it's a perfect time to do a software update. So, first of all, where are things at, just in terms of some raw stats? This is literally the graph I showed from FOSDEM, except we just hit that little blip there at the beginning of the year. In terms of the total number of MX IDs, and this is literally the aggregate stats of every synapse out there on the network going and phoning home the number of users that it has on it. We're up to about 113 million users, up from about 4 mil back in 2018. Slightly different graph showing monthly active users across the Federation reported by the same sort of metrics, getting up to about 3.5 million at the moment. A bit more of a random walk as people come and go, and occasionally people do a load test for 1 million users, hence that big spike there. Well, I guess a month-long load test if they're turning up. Oh no, actually, any load test because it's over the course of a month. But either way, graphs are up and going to the right overall. Something people often say when they see the 113 million graph is, really? I don't know 113 million people on Matrix. And that is because roughly half of them are bridged. And so I went and pulled out the difference between folks who have been tagged as coming in from an application service on the phone home stats versus everybody. And you can see almost precisely half of the people who get reported there are actually being sucked into the Matrix vortex, not of their free will via the magic of bridges, but it does mean that the yellow graph at the bottom, which is now up to, I guess, 62 million, 64 million or so, are the actual real MXIDs out there. That does include guest users as well for full transparency. So when somebody clicks on a random, I know, element.io/app style link, or sorry, app.element.io/link, and they find themselves looking at a guest view of some random room in Matrix, and they will get counted there. But it still gives a reasonable idea, at least of the shape, if not of the absolute axis. So, Matrix 2.0, woohoo! It is not yet a spec release. Lots of concern and panic that we suddenly cut a new spec release and changed the version major number without telling anybody. Instead, we're basically proposing, as we did at FOSDEM, that 4 very big, chunky MSCs, the entirely new sync API of sliding sync, the entirely new group VoIP semantics and native matrix, entirely new authentication APIs, and also the major changes needed to support lazy loaded server joins should, on aggregate, be considered worthy of a new version of Matrix once they land in the spec. So, warned about this, foreshadowing it in the last year's summer blog post, which I think was just before last year's Matrix Community Summit. Then we announced it at FOSDEM, and then yesterday we actually got implementations out there of the native OIDC support, as well as native group VoIP, complete with end-to-end encryption in Element Call. And we obviously already had sliding sync and faster joins out there, so now the all aspects of Matrix 2.0 are ones which people can and hopefully are playing with. So let's go through these one by one. Sliding sync, you probably know it, hopefully love it, may hate it, in that you have to run a proxy to use it. And the idea of sliding sync is that it only syncs the data that you need to render the user interface at any given time. This is inspired shamelessly by me going and opening up the network inspector whilst Discord was open to try to see how they ended up with hundreds of thousands of members in their servers or whatever they call their communities, and saw quite an interesting API where they were literally loading just the bits that you need, and then as you paginate down the list, it goes and pulls in more stuff, but also as that list gets updated, they would go and add things into the list, remove them, shuffle them around, almost a little virtual machine that is telling the client how to render that list based on the window that it's looking at. Now, that's basically the inspiration for sliding sync, and it should give you instant login, instant launch, instant sync. Instant login is a little bit aspirational, particularly if you've got OpenID Connect turned on, or if you're using the proxy, which everybody is, because other than the experimental conduit support, there isn't any native sliding sync implementations out there yet. Obviously, the first time that you log into the proxy, it has to suck up all of your initial sync from your home server, so that will take a while. And there are some scenarios with OpenID Connect where it will do that whenever your session refreshes when you log in to a new device. But in general, for sort of the happy case, instant login, definitely instant launch. So my account has gone from being about 10 seconds on Classic Element to about 100 milliseconds on Element X to launch on iOS, and then always instant sync. And in fact, the profile of the sync timings is a bit weird, because it turns out the initial sync on sliding sync, starting from cold, is faster than incremental sync, very unintuitively. So what we do is to expire your sessions after about 30 minutes by default on the proxy. So after 30 minutes, the proxy just gives up and forgets all about the clients which are connected to it. Next time you try to sync your device, it goes and says, okay, clean slate, let's go get things up and running again. So in case you do notice some slightly slow syncs on sliding sync, this is caused by probably it being about 29 minutes since the last time that you used the app, where there's a bunch of scroll back that's accumulated in 2 device events. And there's this kind of worst case scenario where it might take a couple of seconds rather than a couple of 100 milliseconds to sync. But so far, I don't think anybody's noticed it apart from me, who is particularly obsessed with fast sync times, having been completely traumatized by the agony of using Classic Element on mobile on my account. There have been lots and lots of iterations on the API, using Element X as the guinea pig to drive it forwards. At the beginning, I guess last year, we started off saying, hey, we're going to have a single window over the room list like Discord has, except for room lists. And as you kind of swipe up and down your room list on the phone, it's going to talk to the server and pull in additional rooms at the top and bottom, depending on where you are. And we mocked it up in a little web jig that people might remember. We also implemented it in Element Web, and it felt pretty good. And we felt pretty smug and thought we'd created the ultimate API. And we implemented it on Element X, and it sucked. And the reason that it sucked is Apple made a terrible promise to their users in 2007 when they launched iOS, in that they included things like the photo gallery on iOS, which has got incredible performance. Even on a really crappy first-generation iPhone, you can infinite scroll it as fast as you like, and you will never see placeholder. It will give you this beautifully hierarchically loaded in thumbnails of all of your photos. And as a result, everybody who has ever owned a smartphone has got used to the idea that you should be able to infinite scroll through a list and immediately within a frame see contents without there even being a placeholder. So if you're talking to a server which is like 100 milliseconds away, or heaven forbid you're on a bad internet connection and it's a couple of seconds away, the idea you scroll your room list and then sit there staring at little spinny things for about 2 seconds until, whoop, oh, there are my rooms, would feel awful. So this was a bit of an embarrassment, and we thought, well, hang on a sec, no, not a total disaster. Then we realized that particularly power users navigate their room list by search. Like, I never scroll my room list personally unless I'm very bored trying to find interesting things to look at. Instead, you say, I want to talk to Johannes, and I go and type Johannes in. And if the search isn't absolutely instant, again, it's like, why am I waiting for this thing to tell me where my room is with Johannes? Surely it knows. So again, the latency of talking to the server, even to just do a quick lookup, there could be bad, particularly on a boat with bad connectivity. So all of this basically took us to round 2 of Sliding Sync, where we said, hey, perhaps we should just load the whole room list anyway. So we'll still keep the sliding window in round 3, and we will use this to preload the chat history in the rooms which you're currently looking at. So if you scroll down the list, it will go to the server, pull in the most recent 20 messages of the rooms you're looking at, so that if you click on one of those or tap on one of those rooms, you'll immediately get the chat history. That will be great. But meanwhile, actually, the room list will already be there, and we'll gradually load it in the background, starting with the bare essentials, and then expanding it out over the course of like 30 seconds or so, so that all of the data is there, so you can search it instantly, and you can search through it instantly. And that's how it's implemented right now, today, in Element X. However, we have some additional problems. First of all, the server doesn't actually know the right order for rooms in your room list, because the order depends on encrypted messages, and the server doesn't know what those messages are, and therefore it doesn't know if they're visible. Are they marking your rooms as unread? Do they have keyword mentions in them? And this will be even more true if and when, and it's more like when now, that we encrypt state events, because the server won't even know the name of the room, so it won't be able to do an alphabetical ordering or something like that. So the design on this was always with Sliding Sync that, it's okay, the server can do an approximate ordering, which will be pretty good, and then the client will have to go and spider the encrypted rooms, figure out whether it really was visible or not, and slightly tweak the ordering. And that is, I think, the optimal solution. But the complexity is really starting to ramp up. And empirically, over the course of the year, we've had a lot of iterations to just get the basic API running as intended. And I don't know, for those of us who mess around implementing against APIs, the best API, let's face it, is the one where you do not need to read the documentation, because the shape of the API obviously tells you how to use it. It's nice and intuitive. It isn't full of footguns. Unfortunately, empirically, Sliding Sync is full of footguns, and there are a lot of people who've been working on Element X who are kind of struggling around with a slight limp, having gone and shot themselves. So, long story short, we're very likely to simplify the Sliding Sync API. It will have very similar semantics, at least for the subset that we have in Element X, but we are removing the footguns one way or another. And the idea is that the server will incrementally send the right data in roughly the right order based on what it knows about that data, but then the client is responsible for all of the ordering. So critically, you would no longer have a sliding window here at all. You instead go and gather it up into a big room list, and it turns out that there are many other scenarios where sliding windows aren't actually a good fit. So if you want to preload scroll back for the visible rooms that the user is looking at, if it doesn't match the sliding window, you basically want to just tell the server, give me the messages for those rooms. And likewise, when you're searching the room list, the set of rooms, God knows what it is. So you need a new API of some kind that says, hey, give me all of the most recent messages in this set of 20 rooms. And Matrix just doesn't have that today. So in the near future, you should expect a new API tentatively called /timeline, which will be a little bit like /messages that will both help with bulk loading scroll back for sets of rooms, potentially for helping with grabbing history when you get a push notification coming in, doing so efficiently as possible, and also making sure that it plays nicely with sliding sync, because at the moment there are some fairly embarrassing things which we ironically fixed in Sync v2, but were bugs in Sync v1, which have now come back in sliding sync, or Sync v3, where you don't actually know how to marry up /messages with the messages that you've received via /sync. So just a heads up, the sliding sync, even though personally I think it feels amazing in Element X and is super fast and snappy, is still going to have a little bit of iteration on the MSC before we propose it for merge. Enough on sliding sync. Let's talk about native group VoIP. For as of yesterday, there is at last end-to-end encrypted, scalable, as in many hundreds of people, video conferencing in Matrix at last, which used to be the most common request. In the early days of Matrix, people would say, oh, I mean, JITS is great, but where is the native Matrix VoIP? Well, here it is. So this, again, has gone on a bit of a journey in that nowadays the call signaling is being set up via Matrix, albeit using timeline events rather than two-device messages, which is the proposal in MSC 3401. Although, Florian, are you out there somewhere? Yeah, we haven't updated MSC 3401 yet, right? Okay, so at the moment, basically, this funky new native group VoIP is completely off spec, so we need to update the MSC that describes it. But the current behavior is using timeline events rather than two-device messages, and then for the scalable conferencing, we are using a selective forwarding unit, or a conference focus, basically the thing that mixes together the voice and video feeds made by a lovely company called LiveKit. LiveKit's a bit like Element in that it's an open source startup building on an existing open source project. The open source project that they build on top of is called Pion, which is the excellent Go language WebRTC stack. And you may recall that we were building our own selective forwarding unit in Go on top of Pion. In fact, it was contributed by Sean Dubois, who's my equivalent at Pion in terms of being project lead, who's a fan of Matrix, and thought, I know I can get more people to use Pion if I go and implement a Matrix MSC 3401 selective forwarding unit in it. So we did this. Called SFU to SFU. We subsequently took it over, renamed it to Waterfall, got it up and running to show that decentralized cascading conference servers could work in Matrix, and then realized that we don't have enough people or time to do an excellent job of turning it into a full-blown industrial strength SFU. So LiveKit basically does that. They take the Pion stack and they make amazing conferencing servers on it. So in the interest of pragmatism, we took the Element Core UI, put in the LiveKit implementation in SFU, and signaled the existence of the calls and the membership and when it starts and when it ends via Matrix. And you end up with this hybrid where the kind of high-level call management is done by Matrix, but the actual low-level WebRTC signaling is currently using the LiveKit API. In practice, it works really well. If you haven't played, has anybody not played with the new core.element.io? 1, 2, 3, 4 people. Can we do a quick live demo or something? Let me go and find a web browser. And I guess we're going to have the problem of distributing URLs around the place, because if I go over to here, and we go into the non-standard deal review room, or we go into the Matrix Community Summit, MCS, and I'm just going to hit go on that. Then, first of all, you can see there is a little encrypted sign here. However, the way in which the, Inception, Matthew. The way the end-to-end encryption works currently is that there is a shared secret that is actually needs to be put in the URL when you go and invite people to the room. So it's critical that you hit the share button here, hit the copy link thing, and discover that your element nightly, for a change, has gone and run out of RAM. So instead, I will show you how amazing Element X is on macOS if you haven't seen it, because bang, there we are, my entire Element X account in and up to date. And I'll set poor old Element Web re-going in the background because it will take at least 2 minutes to log in, unlike Element X. So, Matrix Community Summit, I guess is where I should be going here. And I shall go and check the URL in there. And if you look at the URL, you'll see the imaginative word password on the end has got this great big horrible string, which isn't actually shown currently in the URL bar here, because we don't want people taking screenshots or screen sharing and accidentally leaking the thing everywhere. Oh, hello, Timo. Fancy meeting you here. So you can see how this thing is working. And this is using end-to-end encryption, as I say, using a static key for now. But in the near future, if it doesn't fall over, then it will be using proper matrix end-to-end encryption for the identity, using sender keys to actually identify people based on their real end-to-end encryption personae. Some of the nice things we can do in Element Cool is to go and, I don't know, double-click on people and drag things around. We can change the layout so that it does it automatically, or that it's got the grid view to do it for us. I think that's changed a bit. Either way, you get the idea. I think it's awesome. And it's fun to finally have that available to everybody. So we've got 12 people in there right now. This is very new. It's still technically a beta. The thing keeping it in beta, other than just needing a little bit more QA than the 24 hours that we've had so far since this release was cut, is the ability to embed it properly into Matrix. Do I need to refresh this or something? I'm going to blame the connectivity here. I'm sure this isn't the SFU melting. But yeah, but we want to be able to embed it into rooms properly rather than just putting in a web view, and we want to share the Matrix client inside Element Cool with the one inside the host app, which we call Matroska embedding. Right. So the intention here is, well, obviously to replace Jitsi with Element Cool, but then also to converge the full mesh calling that we previously had with Element Cool and the pure matrix signaling with the LiveKit-based signaling in SFUs. In an ideal world, LiveKit would be using Matrix as the API to talk to their SFU. Depending on how well this goes and how well the Matrix API evolves to support this, that might well happen. But for now, we've got a pretty nice pragmatic compromise between something that works, which is still using Matrix, and will shortly use Matrix's end-to-end encryption. And a couple of other things to just call out here is a really nice thing on the LiveKit implementation is that it is literally only subscribing to the visible streams at the resolution requested in the room. So as you go and zoom in on people, it says, hey, hello, Mr. Selective Forwarding Unit, give me the bigger resolution, or hey, that thumbnail scrolled off the bottom because we shifted to a view where it's off the bottom of the page, and it just completely stops transferring media. And even more excitingly than that, if you change tab whilst on Element Cool and wait a second, you will notice that the bandwidth suddenly disappears on your network connection because it realizes that you've hidden the window and no longer need to subscribe to the video feeds, which is kind of nice. Right, moving on to OpenID Connect. So, the great transition of our time, even bigger than when we got rid of self-signed certificates in Synapse about 4 years ago, is the transition to native OpenID Connect. There are so many benefits here, it is untrue. And no, to be honest, when this was first proposed by Kontin, who's been the champion of OpenID Connect and now supported by Hugh, I was pretty skeptical. Because one of the things we wanted to do with Matrix is to make it so easy to use the API, and what's the easier way to log in than go and hand a username and a password to /login, and you got an access token and you're in. You never need to worry about anything else. In retrospect, this was a terrible mistake because it means, for instance, that Synapse still doesn't have two-factor auth. Doesn't have MFA, doesn't have passkeys, doesn't have any of these nice authentication, hygiene, quality of life things which the rest of the world enjoys because we basically accidentally, organically drifted into building our own authentication API. And I think Kontin made an excellent, the point where it really clicked for me was that we had offsite at Element, and he stood on stage in front of everybody and said, I got a hot take. Matrix is a communication API. It is not an authentication API. We should not try to build an authentication API and then listed, frankly, the vulnerabilities that we'd had over the years due to having tried to build our own authentication API. So really, we want to burn it with fire, kill it in every way imaginable, and replace it with proper OpenID Connect. So this will give us the ability to shack up to an existing identity provider with all of the latest bells and whistles for smart cards and biometric scans and DNA samples and whatever else. No more, and from a dev perspective, again, this really came home to me when looking at the Element X implementation. You don't need to waste your life implementing weird matrix auth APIs anymore. You can just pull in an IDC library that will give you a much more polished and beautiful experience for going and actually authenticating the user. And also on the server side, you don't need to do this. And you wouldn't believe the number of home server projects over the years who decided to implement the spec starting at the beginning. And if anybody has read the spec recently, the first 4 chapters of the spec are just about authentication. And so, I forget, I think Pallium was the first one, written by Ericsson in Go, and they started off by doing endpoints there. And Rumor, which obviously eventually became the object library for Rust for Matrix, started off as a home server, and Jimmy Quadra again started off trying to implement matrix auth. Never got as far as creating rooms or sending messages or anything, or at least for months, because you fall into this horrible rabbit hole of implementing this weird custom auth API. So it will make life so much easier for client and server developers. Another big thing is that users will end up sending their password to their identity provider in their home server. They will not keep typing their password into some random matrix client they just pulled off GitHub, which may or may not be logging it to standard output and or accidentally sending it in a RAID shake to some logging server somewhere. Gives you consistent auth and account management no matter what app you're using. So you go and hop onto some fancy new Matrix client and you want to do a basic thing like, I don't know, kick out the device afterwards. You know that you can always go and manage that device membership in one place. It's really good news for password managers. You tell your password manager the URL of your identity provider when it remembers your password, and then no matter what Matrix client you use, it will populate up the password correctly and log you in when you want. Likewise, it will allow you to share your auth between different Matrix apps. So you log in once on the identity provider, switch to a different app you've never used before, and it already knows who you are if you want to. Gives us access token refresh, which is a long-term embarrassment that if somebody spots your access token because you're doing a talk on stage like this and you alt-tab to a terminal and it's sitting there and it goes on YouTube for posterity, hypothetically, then you don't have to kick off that device. Instead, you know that it will only be valid for a couple of minutes. And then finally, it opens the door to OIDC scopes to let users control what features their app can access. So if you want to, I don't know, log into Element Call and only give it access to create video calls or participate in video calls, and you do not want Element Call randomly going through all of your encrypted chat history or sending non-call events on your behalf or something, then you can really lock it down and say, hey, this bot is allowed to only access rooms in this space or this room. All complete vaporware right now, my speciality, but it at least gives us the opportunity to do it in the future. So, is anybody running Matrix authentication service yet? Okay, so admittedly, it was only really publicized yesterday as something that you can do, but this is the way in which we've implemented the new OpenID Connect stuff. In some ways, it's a bit like the sliding sync approach, in that it could be integrated natively into the home server, but again, it's been done by a totally different team in a totally different language, this time Rust rather than Go. And we wanted to work with other people's home servers, particularly whilst we're developing on it. And the approach taken with MAS, or MAS as we call it in English, or MAS as we call it in German, is that you go and embed it into Synapse effectively as a module eventually. But right now you run it alongside. And it provides the basic user interface for login, permissions, and generally looking after your Matrix account, imagine I spelled management correctly, in the normal user interface for OpenID Connect. Again, let me do a quick demo. Is this going to work? Let me try going to the corporate element home server, which I very rarely use. Yeah, here we go. I'm already logged in. Let's go and dump out of this. And, sorry. How do I actually sign out of Matrix Element these days? I do not want my encrypted messages. There we go. So this has been hard-coded over to the element.io home server. And in fact, you know, what I should have done is just go in on, say, develop instead. So you can see the full experience, except, no, sorry, changed my mind. Let's go back to here. So let's go and sign in. It's hard-coded to element.io, hit continue. And this now, you will see the URL has changed to mass.element.io. So this is the element mass instance, and it's got this slightly different vibe because it's being provided by the server. It's not part of Element anymore. It's the server asking for permission to see my profile, view my messages, and messages on my behalf, as you would expect from a fully featured client like Element. Hit OK, give it permission. And, well, as it happens, it's already remembered my SSO session on the key cloak that we run at Element for identifying people. And so that was it. In some ways, the most anticlimactic demo ever, other than poor Element Web now taking 10 minutes to log into my account. And you have to verify it, and you're basically into the normal flow. So I guess I could have kept myself out of Keycloak, or I could do it in an incognito window, but we don't have time. You get the idea that basically it is defaulting everybody to having their login and logout managed by the server rather than being done by the client. And Element X has got really, really nice inbuilt support for this. In fact, perhaps I can show that quickly. So I think this Element X instance here is... Yeah, so that's actually currently logged in on the same thing. If I go here and sign out, blum, and I again hit continue to log back in again. Let's see what happens. About to sign into matrix.org. I do not want matrix.org. I want to have element.io. About to sign into element.io. Hit continue. And this, look at this. So this is now, even though this is an iOS app, it's sufficiently integrated that it's asking macOS to chuck open a browser, which takes me through to the mass flow, hit continue there, and that's it. I'm in. So this is the power of the system, that you can just take a random client like this, and I didn't even need to authenticate myself because I already had the credentials hanging around in mass to prove that I was who I am. Right, where now? There are some limitations. We don't have migration tools for existing home servers yet, which is probably why no one's running this already, but it is coming soon. Also, we don't have full backwards compatibility for normal Matrix clients. Specifically, if you try to deactivate your account, it won't work. If you try to kick out your devices, it won't work. And if you try to change your email address, it won't work. I believe that will be fixed, or can be fixed. But if you want, and obviously you need to have a client that can speak it, which means Element X, Element Web, as we just saw, and Third Room. Faster joins, really not much to say, other than we did all the hard work and shipped it. And the good news is that you can now join a big room like Matrix HQ very rapidly and send and receive messages. However, getting at the scroll back is still blocked on the full join completing, I believe, which frankly sucks a bit because people join the room and the perception that they have joined the room is that they can see what's in the room rather than that they can send messages or receive new ones. So there's still work to be done there. There's also a lot of processing that still happens on joining a room. So it's a bit of a weird one. On one hand, all the hard work happened, and it did speed up a bit. It does need a little bit more work, though, to realize the full potential, and we're trying to schedule that in as best we can. Then, other stuff, Rust SDK. So, talked a lot about the spec and the server side of Matrix 2.0, but there's been a lot of implementation work client side to actually make this happen. All the heavy lifting being done by Rust SDK, and then Element X sitting on top of it. Probably the most important thing from my side is the Matrix SDK UI crate, which was new as of, I think, May, and provides high-level UI abstractions for the more tricky bits of writing Matrix clients like Element X on top of Rust SDK. It gives you a really high-level UI for lazy loading the room list so that you don't end up pulling thousands of rooms into a single UI table in the app, which is, again, a big deal for power users in lots and lots of rooms because it slowed down the whole launch operation. Instead, what it does now is to mix together the stuff which is cached on disk with the sliding sync response, paginate it, lazy load it, and pull it up into the app. Similarly for timelines, if anybody's implemented a matrix client, you know that actually getting a good view of a timeline is surprisingly subtle once you have to worry about redactions and reactions and edits and how do we do threads and all the other edge cases, and you want it to be super fast and you want it to lazy load and all that good stuff. So again, this is a really high-level API for giving you a timeline as basically a list of the things which you should render. Another one is just the sync spinner, which is a surprisingly hard thing to get right in terms of the app telling you when it's showing you stale data or not. So that's all really, really cool stuff. And the amount of work that has gone into Rust SDK is diabolical. So if you're looking for a good SDK, this should be the flagship one from the core team now. Also, on the Rust SDK, we are finally converging the encryption implementations between the new shiny Rust one and JavaScript SDK as used in Element Web and other JS SDK clients. And so this is embedding Matrix Rust, or Matrix SDK crypto from the Matrix Rust SDK, putting it inside the JavaScript SDK so that we are sharing at last the same code base. This is critical. It allows us to fix encryption bugs in one place, get a single code base audited, avoids us reinventing the wheel and introducing new bugs in multiple places. It's taken a long time to get there, but it should, cross fingers, I've been promised, land next week. At which point, you will find that the encryption in Element Web will speed up by a factor of 6, and it might even work. Right, other stuff going on. The Digital Markets Act. Now, lots and lots of work has been happening on the European Union Digital Markets Act interoperability. The whole idea of tech interoperability between the big gatekeepers, the Googles and the Apples and the Facebooks, etc., honestly happened with quite a lot of encouragement from myself and Amandine wearing our Matrix hoodies, going and talking to the EU and saying, you know, if you're doing antitrust regulation here, we have a precedent that shows that it is possible to do interoperable and secure communication, and it's called Matrix, and let's give you a demo, and we'll give you a demo using bridges, and you can see how much it sucks and how much it wouldn't suck if the things we're bridging together natively spoke something like Matrix. And it was honestly a bit of a stretch that the EU would have actually legally mandated interoperability, but they did. So since then, it's been a bit of a roller coaster to try to actually turn this into real life. We mentioned at IETF in San Fran about 2 months ago now that we worked with Google to actually implement a native matrix bridge in messages by Google, or Android messages, to demonstrate how interop could work. I hasten to add, this is very much an experiment. This is not a commitment from anybody to actually have Google talking matrix, blah, blah, blah. But it was really interesting to see a big company like them say, OK, well, you've got to be DMA compliant. How should we do this? This matrix thing looks interesting. How would this actually work? Can we get it talking end-to-end encryption? And it does. I honestly feel quite happy that the reason that we selected Signal and the double ratchet for Matrix's encryption back in 2015 was because Signal was already speaking it, but at the same time, everybody else was selecting it too, whether that was WhatsApp or Skype or I think Google were talking about using it in their products at that point as well, like Allo from memory had double ratchet end-to-end encryption. And as it happens, the dialect of the double ratchet that they use is compatible with OM pretty much. So it was possible to get it all working, including attachments, which is pretty cool. Now, off the back of that, we produced a dialect of matrix called linearized matrix, which is a simplified subset of the protocol specifically for interoperability between really big outfits. And one of the things which became very apparent is that even though we in the Matrix ecosystem very, very much value replicated rooms spread across servers, if you are a company who's been regulated by the EU into interoperability, you don't necessarily want fancy Git-style replicated rooms. You just want to not go to jail, not get fined, and actually interoperate. So we took the cue to say, hey, what would Matrix look like if you have a simpler version which has the same events, has the same signing, but rather than being a full mesh of replication, you have a hub and a spoke, but critically that hub and spoke is compatible with normal Matrix too. So you get best of both worlds. You end up replicating between folks like us, But then if you're a big outfit who needs to implement a big table implementation of it or whatever it is, then you don't have to know what state resolution is, basically. So that's what linearized matrix is and where it's come from. Now, meanwhile, in the IETF, there is this working group called MIMI, the More Instant Messaging Interoperability Working Group. This is formed by the MLS, the Messaging Layer Security Working Group, who, having completed MLS, which you may have noticed is now RFC 9420, an interesting number, is intended to be the next generation group end-to-end encryption system, replacing the double ratchet variants that everybody uses today. Reading between the lines, I think what happened at IETF 115 or something is that the MLS team got together and said, yeah, we did it. What do we do now? I know, let's build a messaging protocol on top of MLS, which is going to be completely hard-coded to MLS, and it's going to use all the best features of MLS, and it's all about MLS, and this is our opportunity to build this interoperable thing on top of MLS. And they may have slightly forgotten about the DMA or the interoperability aspects of it, because the problem that we have right now is how do you get actual Google and actual Apple and actual WhatsApp talking together before March of 2024, which is the deadline for one-to-one chat working in the real world. So I would posit that going and betting the farm and hard-coding it on MLS might not be the smartest thing to do. Instead, you want something like linearized matrix, which pragmatically just glues it all together. As you might tell, there is some friction happening, therefore, between the MLS maximalist purist contingent versus the hacky bridge pragmatic matrix people who are trying to basically figure out whether MIMI is going to be a useful Swiss Army knife to glue things together, or is it going to be the one true platonic ideal of an MLS-based protocol. Watch this space. We failed to get to consensus on it at IETF 117 in San Francisco, and so they produced a design team, which is apparently the appropriate way to solve fights at IETF. And there are 7 of us on the design team. You've got me and Travis from Matrix. You've got Google, you've got Wire, you've got Cisco, and you've got Wicker. And I'm probably forgetting somebody, which is embarrassing, so hopefully they're not listening to me complain about them in the Community Summit talk. Anyway, but either way, we've been trying to get to consensus over the last few weeks on it and have yet to get to consensus. So presumably we'll need to form another design team in order to work on the impasse we have with the current design team. Anyway, talking of MLS, work on implementing MLS on top of Matrix rather than having it MLS all the way down is going pretty well. Hubert, Uhareg to his friends, if you speak Rot 13, has been working away implementing it on Element Web. It even supports key backup now. Go and check it out on arewemlsyet.com. Possibly coming to a labs flag in a room version near you sometime soon. And interesting to note that it uses normal matrix device lists to track which devices are in the room, which in some ways is the root of the contention with the MLS folks on MIMI, because either you basically need a way to track what device is there. Do you track the membership of the group in Matrix, or do you track it in MLS itself? And if you do it in MLS itself, how do you keep Matrix in sync, or do you keep Matrix in sync? So at the moment, our implementation is subject to the problem of server-controlled group membership, which means that a nasty sysadmin can lie to you about the devices present in a room, and you have to rely on verification and trust to spot that somebody has gone and added a malicious device into the conversation. Clearly, that sucks. We need to do better. However, quite how we do that, whether we flush out bad users and devices using Matrix state res, or whether we leverage MLS, or do both, is basically the holy war that is raging within MIMI as we speak. Finally, account portability. We're finally making progress on account portability. This is MSC 4014, which is the second iteration, or third iteration actually, of MSC 1228, if you know your MSC numbers. The work is happening here in Dendrite because this is real Wild West territory, massive vicious changes. Doing it on Dendrite as a relatively young and fresh code base that is there, ripe for the abuse, is much easier than doing it to poor Synapse, which needs to be rock solid and run communication for gazillions of people. And the PR actually merged a few weeks ago. The headline news is that under the hood, it replaces the sender field on events with per room sender keys. And the sender key is per device, no, it's per user, but per room curve 25519 or ed 25519 key to identify that user within that room. The good news is that this version of the MSC means no client changes. Works straight out of the box with existing clients because the server maps the keys back into MX IDs and puts them on the sender field on the event at the last minute in the CS API. Work is going on to try to integrate the user identity of the cryptographic IDs, which we have for these sender keys, with the cryptographic IDs of end-to-end encryption, because it would obviously suck if we have totally different keys flying around for tracking what a user is. And worth noting, it doesn't actually give portability. It's just replacing matrix IDs with these crypto IDs. Good news for GDPR, though, because we are no longer signing PII in the form of matrix IDs into the DAG of matrix rooms. So next up, beyond figuring out this encrypted identity problem, is client-initiated portability. So me as a user wants to move from matrix.org to element.io. How do we do the permissions and the dance and critically the key sharing around that? And beyond that, server-initiated portability, multi-homed accounts, who knows? At the moment, it's a bit of a skunkworks project, much to the horror of some, but hopefully we'll get it less skunkworks in the near future. Final updates. Matrix Foundation is getting proper independence and spreading its wings. We have hired Josh, who used to be president of the Open Source Initiative last month, as the very first managing director and employee of the foundation. And his mission, whether he chooses to accept it or not, although I guess he did, is to make the foundation operationally independent and self-sustaining. So not dependent on handouts from Element to survive, but instead be supported by the wider ecosystem. Please financially support the foundation if you're building on Matrix to protect the project's foundations. I mean, it's really straightforward. A surprising number of really high-profile projects, like LuxChat in Luxembourg, the official state messenger for Luxembourg, does not support the foundation, nor does it work with Element. Many local authorities in Germany seem to end up working with some local vendor who, again, doesn't in any way contribute back to the bottom of the stack. There is massive risk of the classic XKCD cartoon of your dependency tree collapsing because there isn't sufficient support of people building on top. Go to matrix.org/membership to see how to do so. I think Josh is going to do a remote cameo. Jan, this is true? Is Josh? No, it's not true. That's sad. That would have been fun. Oh well. Then finally, next-gen updates. On the Element side, the teams had to focus on Element X, Element Core, doing all the core, well, a lot of the core matrix dev, end-to-end encryption, sliding sync, etc., as well as increasingly having to build commercial products like Element Server Suite, which is awesome, by the way. In the absence of funding from the foundation, though, we've got a problem on next-gen projects. So Dendrite, the team has moved to sliding sync and account portability. Peer-to-peer matrix is basically on hold, but the team is kind of the same as Dendrite, so we're also working on sliding sync and account portability. Low bandwidth matrix is completely on hiatus, although it has been now for 2 years anyway. And poor third room, even though it is still the world's best standards-based spatial collaboration system, is paused indefinitely, and the team is disbanded, with Robert going off to work on a really cool indie game and the rest of the folks heading in respective directions. If you want to see next-gen development happening, the best way of doing it is to put money into the Matrix Foundation, who will then figure out how to get this stuff funded one way or another. And that's it. I'm almost on time. Thank you. Yeah. Do we have time for questions?
Yes, we have time for questions.
We don't? Oh.
We have.
Make up your mind.
Okay, I already have a mic, so maybe I'm first. You already mentioned good... It's me?
Okay. Oh, hello.
You already mentioned good news for Matrix and GDPR on one of the slides. What's your take on this Matrix and GDPR thing, especially for the retention of data? Because like MXIDs are kind of need to be stored forever, or maybe a hash of them. And in general, data is shared a lot to many different places, and it's not sure how it's deleted. What's your take on this? Do you know anything on how well that works?
So back in May 2018, when GDPR came into force, on the Element side, we decided consciously to try to do it right. and be the first decentralized project to basically set a precedent of how should GDPR interoperate with decentralized systems like Matrix? Because we knew that ActivityPub and others would come along and hit the same problems. And we spent a lot of money on very expensive data privacy lawyers to try to go and figure it all out. Now, the good news is that I think Matrix is compliant in all respects other than the personal identifying information in the MXIDs. That is literally why we have MSC 1228 and now MSC 4014 doing these pseudo-IDs. Now, if you look carefully at the terms of use of a Matrix server, it says, hey, we're GDPR compliant, but due to the fundamental structure of Matrix, you need to be aware of this limitation. Are you okay with this to continue? Which, from a legal perspective, is okay. It's obviously a bit unfortunate to ask people to agree to a kind of carve-out when they use the service. Cool. But that is why we've always designed that, and we wrote the original MSC in 2018. I'm very glad we're finally implementing it now in the context also of account portability. But the other bits, like storing all the data forever and honoring redactions, setting the semantic that when I send you a message, you get a copy of that message. It is no longer owned by me. It's on your server. It's like email. Was a really important thing that we wanted to set a precedent for. Because there is the alternative interpretation of the law could be to say, well, hang on a second, it was my message, I wrote it in the first place, and I don't care that I've gone and printed it out and handed it to everybody in the room. I should now have the right to break into your house in the middle of the night and set light to those pieces of paper. I think that's silly, and it's much more reasonable to think, I've given you a copy of it now, I relinquished ownership. But we wanted to get that right, and I think we did. There is a question as to whether you should have mega redacts as the ability to obliterate everything you have ever said in one fell swoop by redaction, so an advisory measure, obviously. We haven't done that. We think it would be massively prone to abuse, frankly. It would be the obvious thing that if somebody owns somebody's account, they can just now put out a little sort of mega redaction that just obliterates from the history of the internet, which on one level might be a win, on the other level might not end up being amazing. And there are a couple of other edge cases that we reasoned through. So honestly, from my perspective, I think we're in quite a good place, particularly with MSC 4014. But it's also a grey area, and we tried to define the rules, and it seems that other people have now copied the precedent that we set.
Right, thanks.
I've got a question about here to your left, here.
Hello.
I've got a question about sliding sync. Do you have a tutorial for people like us who run their own home server? How to set it up, preferably in Docker or something?
Yeah, so Thibaut Martin, our amazing developer advocate for the Matrix Foundation, has done a really nice little YouTube and written tutorial, which if you use your favorite search engine and just look for sliding sync tutorial, it will come up because I did it yesterday and found the URL. I think people are unnecessarily worried about the hassle of running a proxy because it sounds like, oh my God, I've got a totally new thing to worry about. I've doubled my system in complexity and all the rest of it. In practice, it's a pretty simple system. It's a one Go process and a Postgres database, and it doesn't have any configuration. It doesn't even have a config file from memory. You set it running, and it does its thing. The only failure mode we've seen with people running it has been forgetting to upgrade it because they forget it exists, because it's just sitting there in the background. And because, as you heard, we are iterating like crazy on sliding sync, you get really weird behavior if we fix a bug on element X, which requires a matching bug fix on the proxy, and then it all gets out of sync, and we get lots of bug reports. In fact, I think the only sliding sync bug reports we've had in the last last month or so have been due to stale sliding sync proxies. Adding it to a Docker compose should be really simple because, again, it's such a simple thing. Probably the only real bad thing about it is that it does increase your storage footprint. So not only do you have Synapse tracking all of your messages, but now you've got this cache basically being managed by the proxy. But don't be scared of it. Please give it a go. There was some guy on Hacker News yesterday after we launched Matrix 2.0 who came in saying, why are you making me run another thing? I hate you. And then literally 25 minutes later, he came back saying, oh, actually, that wasn't so painful after all. So hopefully, give it a go. And obviously, it will end up natively in home servers eventually anyway, but we don't want to rush it because it would be stupid if all the home server implementations enthusiastically did their perfect sliding sync implementations, and then we turned around and said, well, you know that bit where we said we were going to simplify it lots? It would be very frustrating. So let's get it stable, get it MSC'd on a proxy, and then that's the point for everybody to go wild and make it native.
Hello. Hi. I would like to know how, or if there is a roadmap to deprecate the old SDKs, like the JS SDK or iOS or Android SDKs.
iOS and Android SDKs are dead, deprecated. JS SDK is not. It's used in the basis of Element Web. It is used obviously in lots of bots and bridges, and instead we've gone and taken the Rust SDK crypto into it. I imagine it's going to be there for the foreseeable because there are just so many things using it. And honestly, no, let's see how well it performs with the Rust crypto and the JS layer. We're not sure what comes next for Element Web and whether we replace we try to replace the whole thing with Rust SDK, or whether we keep polishing JS SDK, or we do a gradual convergence. Johannes, if you're out there anywhere, we've got Johannes, or has he fled wisely? He's responsible for figuring out what we do with Element Web.
So this will also include security fixes?
No, I mean, there's a difference between deprecated, as in we're not doing anything to it, versus fixing security. And obviously, there are a lot of apps out there who do use the legacy iOS and Android SDK too, and for security stuff, yeah, that will continue to be supported until, well, probably the last people seriously use it.
I see. May I ask a second question about OpenID Connect?
Yeah.
So eventually it will be possible with Synapse to just hook up something like a key cloak to it, which will then take over the authentication flow and give you the actual key cloak access token, which will be used to authenticate against Matrix. How will devices and sessions be linked eventually?
I think there may be a nice diagram of this. If you go to Matrix Authentication Service here, or where's the actual project itself? Right, yeah. This is basically what's happening under the hood here. So, you can't say, sorry, it's just Jan's fault. Either, well, take it from me that you've got a fancy diagram where you've got mass as the kind of matrix-specific IDP shim talking both through to the upstream IDP. Yeah, there we go. So you've got mass here with a compatibility layer for old matrix clients. You got something like Element X or whatever talking OIDC to this, talking through to Keycloak for upstream OIDC support. And I think your question is the green arrow that the home server now has to rely on mass to determine validity for access tokens. And likewise, if you want to do migrations between the accounts there and the ones being managed by mass, then you need to have some kind of dashed blue line. So the answer is it's a green arrow.
Nice. And mass will eventually become part of Synapse then, or?
I think mass has been designed to be a really, really lightweight chunk of Rust, so you can pick it up and embed it into Synapse to the extent that it would be pulled in like the other Rust dependencies that Synapse has today, like some of the hot path state resolution stuff or presence or whatever it is.
All right. Thank you very much.
That's okay.
Hi.
Hello.
So I have also two questions. So the first one, how does the Matrix SDK crypto, the Rust thing you mentioned, compare to the crypto stuff that was introduced at FOSDEM? And does that fix the common encryption issues?
So it is the same as I was hyping FOSDEM, the difference being that it's now landed everywhere. Jan, you've got a hot mic, by the way. Jan, you have a hot mic.
What?
You have a hot mic.
I have a hot mic, are you sure?
I can hear you over the microphone. So that's right. So yeah, it's the same thing that we announced, or that we've been working on for ages, honestly. The difference is that we're now finally at the point of putting it into Element Web as well as everything else. So the code base is, what, probably 3 years old now? And the actual encryption implementation for the DOSMATs, the kind of low-level crypto, is relatively new. I guess it's a year and a half old now. But we got the DOSMATs audited, and it works. And frankly, using Element X to talk to other people on Element X right now, it works. I haven't had any of the classic nightmare, weird race condition UTDs or UICs of the past. So hopefully it will fix things, unless it turns out that some of the problems are on the home servers. And I have a hunch there is still a bug where two device messages, when you federate them across servers, can sometimes get lost. We've never reproduced it or caught it in the act, but in the end, if the traffic doesn't flow, then the encryption isn't going to work.
So this is, if I'm correct, at FOSDEM, or right before FOSDEM, there was a beta on iOS. So this is the Element Web add-on to that.
Correct. So the beta for Element iOS and Android shipped like months ago.
That's why I was asking.
And should have improved the encryption reasonably there. But because, let's face it, over half the people on Matrix are using Element Web rather than a mobile thing, even though we'd made iOS and Android work, the perception of flakiness was still completely undermined by the buggy old web. So that's why it's so good that next week, hopefully, we get everybody speaking the same crypto dialect.
That would be awesome. And the other question was, is linearized matrix planned to work with the DAG, or will there be separate room types for hub and spoke and like the full mesh rooms?
So linearized matrix, frankly, is a bit of a straw man to throw into the Mimi work to say, hey, look, if we just build this Mimi on top of matrix, it would look like this. The problem is that other people have very strong ideas of how it should look, which doesn't involve any matrix at all. So that is why we're now stuck in this tug of war, trying to figure out what blend of linearized matrix and what blend of MLS maximalism you would use to build this protocol. So to answer your question, yes, it's got a DAG. It's a linearized DAG, so it's a linked list. And if you interop with wider matrix, then you would have the bushy tree-style DAG, and you would linearize that on the hub, which is talking through to the linearized side of things. So it worked really nicely as a model for interop. But you would not believe the level of tension arguing about whether it is the responsibility of the transport or the signaling protocol, i.e. matrix, to sign messages into a DAG, or whether that should all be done by the end-to-end encryption, i.e. MLS.
I see. So I guess you're really trying to do, okay, we can compromise on the transport, but we really want that message format to even have interoperability with matrix in the end.
Yes, and then the message format has also drifted off with a proposition coming in which is identical to matrix in all respects, except every field is named slightly differently, and it uses TLS presentation layer as the serialization format rather than JSON. Not saying that we should use JSON, but that's the kind of tension that we're seeing.
To be honest, that has advantages to signing, though. Canonicalizing JSON is fun.
Yeah, it is, totally. And we need to get away from JSON and canonicalize JSON. Use the binary format. Perhaps TLS presentation layer is the right answer to that. Does anybody think that TLS presentation layer, the thing that you use to negotiate TLS these days, would be a good serialization format for matrix events? You may not have strong thoughts on this, but you may. Stunned silence. Okay.
Thanks a lot.
Sorry, we're overrunning on timing, I think, maybe, or not. Jan is looking.
I think it's all right.
Well, with that said, any other questions? Or, oh, there's one there.
Yeah, thank you for your talk. I work for a larger German public sector. And if we want to put money into matrix.org, or the matrix organization as such, depending on the amount, we need to tender and such stuff. With whom can I talk about that? That we get a solution where we can put money into the matrix org, and at the same time don't get run over by our accountings.
So I think there are two ways of doing it. Either you go down the non-profit route and you donate to the Matrix Foundation, which, as I said, is now increasingly operational in terms of selling memberships. So, I think there's no limit on the size of the membership, but the largest tier is $500,000 a year, intended for big public sector and private sector organizations to say, right, we like Matrix, we're building on it, and we want to make sure that the core project is safe and sound. In terms of negotiating tenders for justifying a non-profit spend, honestly, I've heard that's quite hard, particularly in Germany. I'm not an expert here. You may be better off talking to Patrick, who I saw lurking around, who works at Element with me, but is also the managing director of our German GmbH, and so has more experience of procurement shenanigans. Alternatively, right now, about 95% of the work that goes into the Matrix Foundation is donated by Element. So an alternative route is to buy something from the nice people at Element, which then relieves the pressure on them donating stuff to the foundation. But I'm wearing a Matrix hoodie today rather than an Element CEO one. So come and talk about it afterwards and we can try to figure something out. There should be a way though, because if it's just procurement logistics stopping people from supporting the project, that really feels like it should be a tractable problem.
Yeah, thank you.
And thank you for being up for contributing. Any last? Oh, we've got a final one here, if we're letting him go again.
So I've got a question on the VoIP stuff. Is it planned for some time in the future to also use Matrix as a transport layer for the data? Because when at some point in time we do peer-to-peer via, for example, Bluetooth or so, the whole WebRTC IP-based thing won't really work anymore because we may have peer-to-peer nodes which are not even connected to the internet. So they will be excluded from Matrix call, whatever it's going to be called, VoIP. Is that right?
So I personally don't think we should put large amounts of real-time data over Matrix. Matrix is great as a rendezvous protocol in order to set up a WebRTC stream or negotiate a live kit, SFU, or whatever it is. The idea of trying to put large amounts of binary real-time data into a Matrix DAG or even two device messages just feels like it's a good way to DOS your home server for absolutely no good reason when it can go out of band between the clients. Now, for peer-to-peer Matrix specifically, we effectively have an overlay network in the form of Pinecone, which is heavily influenced by Yggdrasil, which is another overlay network, which actually gives you an IPv6 network. So even if it is going over Bluetooth Low Energy or carrier pigeon, you can still get an IP overlay that you'll be able to hand to WebRTC. That's not exposed currently in Pinecone in peer-to-peer Matrix, and at this rate, it's going to be a while before that comes up. But at least when running over an IP network like AirDrop or AWDL between two iOS devices, I've done peer-to-peer VoIP calls, and it worked without a single line of code being changed in the client because it just negotiates WebRTC over the IP that is there.
Right, perfect. Thanks.
Okay, thank you, Matthew. Thank you, everyone.
Thanks, everybody.
So there is now a lunch break, and in that lunch break, you can catch up with Carol. Carol, she brought us some bags from the Ansible community, and if you like to have a proper rucksack, you can get one from her now. We will go further here at 2 o'clock, right? Yes, with implementing end-to-end encryption from the scratch, or support coordination at Thunderbird in the backstage. And if you're hungry, grab something from the brunch bar. And if you are thirsty, grab something from the bar.
Warte ich auf irgendwas? No, okay. Ah, okay. Deutsch, English? English? Okay. I will try. As already mentioned, this is from scratch. So in the 10 minutes before this talk, I started preparing the slides. As such, they are not very finished yet. But also, this is supposed to be a workshop. So I'm not sure if you can see the URL over there. Maybe I can. It's just matrixsummit.pad.neco.dev. And if you have a laptop, then you can open the slides and come along, because you can write some code. Because this is supposed to be a workshop, and we're going to implement end-to-end encryption from scratch together. We'll see how far we can go. Everybody got that far? And did the website actually work on a computer that's not mine? Anybody could open the slides? Maybe some feedback? Okay. Then let's start. First, a disclaimer, because many people asked me about that already. From scratch is a very vague term. So we're not going to build our own CPU. We're not going to implement AES. We're just going to use an ON library and then do all the matrix stuff that happens on top there. So we're just focusing on the part that's actually happening in the matrix spec. Then what do we actually mean when we say end-to-end encryption? First of all, it has a very basic goal. I just tried to summarize it here. We're trying to send messages which are only readable by the person that we intended to read the message. If that's our basic goal, we can then split it up a bit more. This means that if we actually want to send it to a specific person, then we actually need to have some identity for that person. We need to be able to verify that identity, and we need to somehow be able to authenticate the identity so that they can prove that the message they sent was sent by them. And then the other part, if we're not talking about the other person receiving the message, we're also talking about encrypting the messages, which usually for us means that we're encrypting a message in a matrix room, and we're sharing somehow the keys that the other person that should decrypt the message can decrypt the message. Then there are some advanced things that people usually want to do. They somehow want to back up their keys, because when they sign into a new device, they actually want to read their messages for some reason. They want to somehow, and then again, the connection to the stuff up there, they want to somehow verify that the message they sent was actually sent by them and not by some other person that had access to the home server. Those are the very basics. I'm going to interrupt it a bit with some other terms that we might use later. I usually mess those terms up, so I always write them down for me. We have the ciphertext, the plain text, and the clear text, and they have some meaning in encryption. The ciphertext is usually the message after you encrypted it, just the base 64 encoded encrypted text usually. The plain text is what we had before the encryption, and then the clear text is what we usually send to our matrix server, which has some extra information like, okay, send it to this user in this room, which is then information that's not encrypted, but it also has the ciphertext in it, which is the encrypted part of the message. And then another term already mentioned when verifying the identities, you want to be able to sign something, which is basically similar to when you sign for a package. You add some information that hopefully can't be falsified, that proves that you sent a message and not someone else. So now let's jump right in. Oh, I forgot one picture. Now, if we look at encryption in Matrix, you can roughly split it in different layers. You first of all have your cryptographic account, which is usually called the OLM account, which has your identity keys, which you can use to sign messages. You can use it to generate one-time keys, which can then be used for encryption between devices. And you can use it to generate OLM sessions. And it can also verify signatures, since it also can sign stuff. Then below that, we usually have the ON layer, which is great to read on the slides here, but whatever, which is then the part that happens between devices, where we send messages between devices, and those are encrypted with Olm. And we use the Olm account to create those Olm sessions and the keys that we need for it. And usually that layer is used to then share mega-Olm keys, which is the layer below it, which is then the mega-Olm layer. This is used for room messaging. This is then the actual messages that we send in the room. Might already be confusing because I'm going pretty fast through that part, but we're looking at all of those layers in detail later, and this is just an overview that you know what we are talking about. Then on the mega-Olm layer, that's used for the room messages, and there we have keys that we can actually back up, that we can export, and we have some index for the messages, while the on layer is double redshift, similar to this, what Signal uses. And then below, above that, now that we can send encrypted messages, we have a verification layer where we can sign our own devices. We can cross-sign our devices so that we don't have to verify n devices every time, but just one user. We have some protection against using a key multiple times, because if someone gets the key once for a message, then they could, in theory, use it and to send a message that looks like you sent it. So we want to prevent that usually. And that's also important that here we actually have some interface to the user so that the user can see, okay, the verification here failed, and this message should not be trusted. And then the lowest layer is then not something we will look at today, but just how you can back up your keys on the server side, how you maybe back up a whole device on the server side so that when you sign in, you can get all the messages that you received while you were offline, and a few other things, but we're not going to look at that layer today. Then the first one I mentioned is the account. This is very important to not confuse with your matrix account. It's a cryptographic account that you can generate, and that has an identity which is done using two cryptographic keys, an ED25519 key and a CURV25519 key, and on every login you generate a new account. So obviously it can't be your matrix account, because on login you usually sign into an existing matrix account, but generate a new Olm account. And this is then what's used on the to-device messaging layer for the encryption, because that's actually your encryption target that you're sending the message to. And this account usually gets a device ID from the server side, but never use that to verify the trust with a device, because that's a server-generated key, and you can actually on login say, I want to have this ID. And so obviously it can't be secure. You actually need to verify the identity keys to talk to other users, and the device ID is just used for the routing between the devices. Now we come to the workshop part of this talk. As you can see, there's actually an editor here. If you have these slides open, then you can actually open them and edit the code and play around with it. This is using Dart, which shouldn't be too hard for you to use if you use JavaScript or anything else like that before. It's not that complicated of a language. It was designed to be simple, but that's what we use at Family. So that's what I used here. And here we use the Vodo-Osimerk library and some bindings generated from the OpenAPI spec of the matrix spec. So there's not much magic there. It's just stuff you can either use as a library already, or that you can just generate from the spec directly, so that you don't need to do a raw HTTP calls. And so now let's just walk through how we would create a new account if we wanted to do encryption. I'm not going to do the login part yet here for now, because we're just looking at how we create the account. Then maybe we can look at how we actually do the login and upload that stuff later. First of all, we assume the user has a user ID, and since we signed in, we already have a device ID. And so the first thing we do is, with the library that we have, we just call account create. Here this is generic because it can be either the ORM library or the Vodosimac library, but in the backend, because if you look up here, we loaded the Vodosimac library as the backend. It's now using Vodosimac. And then we can generate the keys that I talked about before, like the account create here already generates the identity keys that we need for the encryption. And then we have some stuff that we will need later in the to-device messaging, which is a fallback key, and the one-time keys, which we can also generate here. And then usually the next thing we wanted to do here is then upload the one-time keys that other users can see it, as well as our device key. But if before we can actually upload our one-time keys, we want to actually sign them, which is done by just shoving that into a JSON blob with the key and if it's a fallback key or not. And then we just generate the signature for that JSON blob by JSON encoding it and signing it, and then base64 encoding the signature. And that we now do for all our one-time keys, and usually are one fallback key, but the APIs are weird and they always can return multiple keys in the libraries. And then in theory we can upload it, but here in the code I just put it on the side here in the HTML block and print out the other keys so that we can look at them. So now if we run that, we can see that we created an account. This here is the ED25519 key for that account. Won't tell you much, but just that it succeeded. And if we look at the console output, we can actually see that we generated here our one-time keys and our fallback keys, and these are then what we would upload later. We won't go, I'm now going to go over the other layers that we have and just explain them first, and then we can maybe group up and see if we can actually get it working and send messages between each other. Because there's actually, for these slides, there's also a home server I set up, so you can just call the stuff up here, the client new user, and it will generate a new user on that account, and this, on that server, and you can use that to message the other people here that have access to those slides. Now we have created our ORM account, so we want to look at the next layer, the to-device messaging, which is then used to send messages between those different accounts. The ORM layer is, as already mentioned, it's double redshift, which you need 4 keys for, 2 one-time keys, one you generate yourself on demand when you create the session, and one from the other side that you download from the server. And then the identity keys of the 2 participants, which is important so that you can actually know only the person who has the private key for that identity key can actually decrypt the message. This is then used to send you can use it to send a message to each of the accounts. Usually people have multiple ORM accounts on their matrix ID, so you use encrypt one ORM message for each of those devices that every participant has, and then send them all together in one send to device call. And yeah, they can only be decrypted if someone has one private part of the one-time key and one private part of one of the identity keys. And these ORM sessions is something that usually people aren't quite aware of, but an ORM session is reused so long until it breaks. It doesn't have a rotation period usually, which means that if your ORM layer breaks and nobody notices it, then the encryption between those users will just be broken forever. There's one recovery mechanism that the other side then creates a new session and sends you some message. Then the new ORM session will be created, and I think some clients also have some way to drop the ORM session and create a new one. But yeah, usually you store that session and use it until you notice it's broken. Then when we actually encrypt an ORM, yep. How it can break the ORM session. That can, for example, be if you miss a few messages in between. then it can be that you can't decrypt the new messages anymore. I think there can also be just that you lost the private part of your OIM session, and then you can't decrypt it anymore because you have obviously not the private key to decrypt it. And there can also be cases where you, because it's a double ratchet, and if you don't persist your OIM session properly, and then ratchet it forward from the old point to again, then the other party will think, okay, you did something bad, and so it will say it can't decrypt it.
So a few times I've tried where friends put up their home server again after a year or something. And we can message each other until we message each other in a different room, and then the original room will work again. Could this be it? I've seen that happen.
I don't think so. Well, this is on a to-device layer. So there you will be using the same OIM session for the different rooms. But what of course will happen that in the new room you will create a new mega-OIM session, which would need to be sent over the OIM layer. But I can't quite tell from your case if it's just that the mega-OIM session doesn't arrive and you already had one for the other room, or that or that it's the OIM layer that breaks in between. It could be that, for example, if you start up if you use the database backup and restore that to an old state, that now if it will send out old OIM messages which won't be decryptable. And that would cause things to break if you send an old OIM message again, I think. And some cases like that where it could also break if you like skip OIM messages in between. Then we now have these sessions that we can use to encrypt the messages. Now for the actual messages that we want to encrypt, there's actually two types of messages, because as I already mentioned at the start, there's one identity key that we generate on our own when we send one-time key that we generate when we send a message, and we somehow need to transmit the public key material for that. So we have the pre-key message, which includes the public key material for that. And then once we have acknowledged that the other side actually received that key material, then we switch to normal messages, which are much compacter because they don't need to include the public key there for the other side to use the encryption. We can only do that when the other side has actually sent us something back, because otherwise we can't know if they just didn't receive the other OIM messages. And because OIM tries to be resistant against that, we just wait for the other party to send us a message, and then we switch to the normal message format. And then after each message, as already sometimes mentioned a bit before, we have a ratchet that we increase, which adds some new randomness to the session, so that if someone had a key in between, but then basically if we have 3 messages, and someone actually could decrypt message 1. If they didn't receive message 2, then the ratchet ensures, because it's a double ratchet, that they also can decrypt message 3. And that's also then what causes us decryption problems if we drop the message in between, because now we can't decrypt the messages anymore. Now, OIM distinguishes between a message I send out and a message I receive. So outbound is when I want to send a message, and we're just fixed. We're just going to quickly look at some code. We're not actually going to step through it because it actually doesn't work that way it's written right now, since this is supposed to be a workshop, and also I didn't finish the slides yet. If we want to send someone else a message, we first need to query their keys. So we ask the server for the other user, and possibly we can say their device ID, or we just query it for all their devices at once, give us their identity keys. This is just the public part, and there's no way to this is not verified yet. So usually we want to do some verification step there that we now skip for now to actually verify that this is the identity keys for the right user and it's not something that the server gave us so that it can decrypt all the messages in between. Then we have those identity keys for the user and we assume just for now that they are verified. Then we also need the one-time key for that user, which is not done doing query keys, but doing claim keys, because that can only be used one time. So someone needs to claim it, and then it gets removed. And then this key, we can actually verify that it matches to the identity keys if we verify the signature on it, because it's signed by one of the identity keys. And that way we can know, okay, this one-time key actually belongs to that identity key. And then after we have the one-time key for the other side and we have the identity key for the other side, we can then create the outbound OLM session, which we can just do on the account. And the account also takes care that it uses our identity key and generates a random one-time key for us in this case. And then we have a session, an OLM session, and we can use that to encrypt some plaintext message. And then we just send it to the other side. We're using the send to device message server endpoint. And we need to tell the server which users to send this to, which device ID to send this to, and then we have just the event body, which has a type. In this case, it's encrypted, so it doesn't actually have a type that people can use. Or that tells us something about the content. Then the messaging algorithm, in this case, we're using OLM version 1. And then who we are, so our public identity key so that they can look up the right OLM session to decrypt it, and then just the ciphertext of the message. And the message type here is 0 or 1, depending on if it's a pre-key message or not. Now, assuming this worked and the code was actually working, the other side should have gotten a message, and they then need to do something similar. They need to look up our identity keys and then create an inbound session so that they can decrypt the messages. So here again, first we query the keys, and then we look up the key not by the device ID, but by the sender key that actually contains the correct key material. Hopefully we possibly do some verification here that this is actually the right identity key that matches the user that we expected to map it to. And then we look first if we already have an OLM session for that user. Obviously, here we won't have that yet because we never did that before. But first, you always want to check that you use an existing OLM session so that you don't get forced to create new OLM sessions every time, and possibly which could possibly be used by an attacker. So here we just look into our database if we have for the user and the sender key, if we have an OLM session, and if we find one, we can just use it to decrypt the message, and that's just the one call you need there. If we don't have one, the message type is already a normal message type, then we can't decrypt the message. This is one message you might get in Element, or it possibly doesn't show it to you anymore, but that the ON channel is corrupt and it can't decrypt the message. This is if it received a normal key message but didn't actually have a session for it. If we if we receive a pre-key message, we can then create the inbound session, and this just uses the sender's identity key and the message body for the message. Then we can use that to decrypt any future messages, and we should somewhere start. This is pretty much all we need for the on the ON layer. Now we have, assuming this all works, we have some way to send messages between devices that are encrypted, and we can somehow verify the identity. So now we can use that, hopefully, to send messages into a room. The room messaging doesn't really have a way to verify who sent that message. The only way you can verify who sent that message is because you know that you got it from some specific device on the OLM layer. And if you back up the keys or something, then there's no way to verify the identity of the key anymore. And this is a bit annoying, but it does ensure that messages that are sent into a room can be tracked back to a user without having to assume that it possibly could also be sent by someone else. And yeah, you only know that someone encrypted it because they sent you the key for that message to decrypt it. For the room messaging, we're using Megolm, which doesn't really have much in common with OLM, but has a similar name because it's in the same library. This is, instead of a double ratchet, it's a single ratchet, so it has basically an index that counts up for every message and is used to derive a new key. And if you have, you can share at any index, you can share this Megolm session to other users so that they can decrypt messages with that index or a newer message, but they can't decrypt messages with an older message index. Usually you should share that with everyone in a room, but if you say you only want to actually send it to verified users because you actually want to end encryption to be secure, then you just have a subset of users in the room that you send it to. And as I already said, because you can decrypt all future messages encrypted with that Megolm sessions, if a user leaves the room or removes one of their devices, then you need to generate a new key. If someone new joins, this isn't as big of a problem. You can just share them the key at that point. But if they leave, because there's no way to prevent them from just ratcheting the message forward, you need to generate a new key. Megolm, if you look into it, is basically just a symmetric encryption. It's just an AES key that's generated basically and has some way to sign a message that you actually have the sending part of the Megolm session, but it doesn't transmit any user signature. And it has some magic to how it generates the key so that you can actually go backwards. And yeah, as already said, it also distinguishes between inbound and outbound because the outbound part only has the way to add the signature and the inbound part can't actually add the signature that says, okay, I encrypted this message. For the outbound messaging is very simple. There's no need to query any device keys or anything. You just create the outbound session, then you can use it to encrypt stuff. You maybe want to actually back up the inbound part of the session so that you can later read your own messages again. But there's not much to the Megolm stuff. That's actually the simple part. If you look at this in the code, this is called a group session in the libraries because you're can send it to multiple parties. It's very confusing to me, the name, but that's how it is. And you just create a group session and then you can use it to encrypt messages. For example, here we have some payload and we just call encrypt on the group session and that gives us back the ciphertext, which we can then put in an event that we can send into a matrix room. There's something I do here is that as soon as I create a session, I also create the inbound session for it, because if I first encrypt the message and then convert it to an inbound session, then I can't decrypt the message I just sent. I just encrypted because it's already ratcheted it forward. And yeah. Also what's important is that you actually then persist after every time you encrypt a message, you persist the group session. Because if you don't, then other clients will see, okay, you used the same message index twice. Someone is trying to do something weird in this room and then will fail to decrypt both messages. And the same thing is with the inbound session. If you don't persist it early enough, then you won't be able to read your own messages. Then for the other side, that they can decrypt the messages, we basically just send them the inbound session. And they can then use that to decrypt the messages. Because they got it on the OLM layer, they can use that to verify, okay, who sent me that key. And if they don't have that information, then they can't verify who actually sent the message. We can look in multiple places for the key. We might have stored it in our database already. We could have stored it in an online key backup. Or we can also ask the sender to send us the key again, although we can then verify that it was actually intended to be sent by them. This won't work with the Rust SDK because the Rust SDK doesn't answer to key requests from other users anymore. But it works with any other client. And then usually some code is there checking that we haven't used that index before. So how does it work? We look into our database to find the inbound session. We looked it up by the room ID and the session ID that's in plain text in the event. And if we find it, then we can use it to decrypt the ciphertext of the message, and that will give us back the plain text of the message and the message index. And then we need to look into our database if we have already. I think this logic is actually the wrong way around here on the slides. We use it, look up in the database if we have already used that index for a different event ID. Yeah. This is about how much as we prepared for the talk. Now we can go over to the actual workshop part, if you want. And we can try it if we can send actually encrypted messages to other users here, if you want. Or if you think that's maybe a bit too much, I can also quickly go over how the verification stuff in the upper layers works. I don't know. Do we want to actually try out implementing encryption, or do we want to look at the other stuff? Okay. Now, let's see, what code do I have in here? Yeah, now probably it's easier if I go to the... Yeah. So this is the code I showed before, where I generate actually my identity keys and the OLM account. So now we actually want to use it, do that for a real user. So first of all, we need to actually create some matrix client and a user for it. And then we can use that to actually have our user ID here. So, oops. In this case, I actually have this client code and stuff that stores the user ID and such. I can quickly show it to you. It's just here. It just inherits from the Matrix API and stores the device ID and the user ID and the access token and everything. And so that's why I can access it up there again, because that's the user ID and the device ID is what you get back from login or from the register call. So I can't. That's how I store it here. So if we run that, then we should see, and we probably want to comment out this one. We can see that it should register a new user. In this case, demo 635095. And then it generates the signed keys for that user. Now that we have that part done, we want to upload those keys. I did have the upload keys calls up there already. Map string invalid type. the wrong one. What was the call that we were trying to call? Upload keys. This ones are device keys at matrix device keys, which is not a name parameter.
Could it be that just the latest semicolon is line 67, that you miss space?
That too, but first of all, because this is an API wrapper and it has some structures for the different types, this here actually wants matrix device keys, which in a constructor expects the user ID and the device ID, and the other parameters, list of algorithms, which is this here. Because we support OLM and MegOLM. And then we also want our keys, which should be the identity keys, I think. Oops. Account, identity keys. Yeah. Oops. And we need the one. Then this parameter is device keys, which should be a map from string to string, so the device ID to the key, which should be this. And if I actually look into that, yeah. here we have our device ID. Why does it sign the key here? This is the JSON. Now we also need the signatures here for our device keys, actually, if we upload them for the first time. So what we need to do here is, if you look into the spec, the signature object looks like this again, where we have our user ID and our keys that are actually signing this stuff. So in this case, we generate that by our sign keys function should already be doing that, where it generates the signatures with our yeah, okay, that's basically what we need to do here. So I think I did that somewhere else. So that's why it's not here. Here. Okay. Oops. This is the signatures for. This is the signatures for the whole keys object after we already dumped it. So that's why we need to actually. Here we have our device keys. That we are uploading, we actually need to store them. And then we can actually assign it by our key. Converting it to JSON. And then signing this with our account. This is the signature for our keys. And then we can just add that to the keys again. Here's the signature for our user ID to our device ID. We actually need to prefix this with ED25519 because that's the key that we use to sign it for. To sign it with, and then we should be able to put our signature here, and this hopefully should now work if we upload this. So if we try to run this, let's see how far we get. Probably should print something after it. Yeah, and then we actually uploaded the keys, so in theory someone else should be able to query the keys for that user now. We can probably also do that ourselves. If we here, then just client.query keys for our user ID. So let's see. Yep, we can see that we actually managed to upload those keys to the server. So now we just need to create a second client and try to message ourselves. Going to just duplicate this here. So we then want, this is the setup for one user. So we probably want to do that also for the other user. Let's call this one now Alice. And we can call the other one Bob. And now we can do the same here, that we instead query the keys from the other side. And this should now also be successful. But now we just have it for that the other side can actually see our keys when they query it. And then we can try to see if we can actually send them an encrypted message. Over to device messaging. Maybe first we, instead of sending an encrypted message, we just try to send a normal message to the device message. So we do Bob wants to send a to-device message. Of type transaction ID we don't actually care, so And the message that we want to send, we can just make it something really generic. Right. Because I want to send a to-device message, we actually need to tell it here first which user we want to send it to. So this is the user ID. Then we want to send it to a specific device ID. And then we have our actual message. And then we obviously want to receive that message also from our first user if we actually could send this. So we need to do a sync call. And this should, oops. And then we can see what we actually received. Yeah. So we received the sync response, which includes some presence events, which we don't really care about, and account data events, which we don't care about. Okay, we want to simplify this a bit. Where was I? Dot to device. We just care about our to device messages. And we did receive our event. Now I guess what I could also do is just have here a sync loop running and you try to send me messages. But maybe that's a bit too much for something where I'm standing in front of you instead of sitting. It would probably be easier if we were sitting around the table and we could try that out. But yeah, since we can't do that, now obviously we want to encrypt the message. So instead of sending this device message, we actually try to see if we can encrypt it. If we go back to how we actually did that, we can see that if we want to encrypt a message, we actually need, since we already did that, that we queried the keys, we also need to upload the one-time keys now, which we skipped before. This we do with one-time keys. Oops. So now on the other, since we now upload the one-time keys as well, on the first time we should be able to claim them from the other side, which is, so here we have the, wrong slide. We also want to claim the key. For that device. Oops. And we also need to tell it which keys we actually want to claim, which, did we have that here? Claim keys? Nope, of course I skipped that part. Nope. And if we look here, claim. We want to claim our assigned curve key. Oops. And this should now give us the keys that we wanted to have for the other party. No, it actually failed. No, it didn't. Uh-oh. Did I just delete the code that I just wrote? Yep, I just deleted the code by accident. I think we'll cut it here because I don't want to. Yeah, I just deleted the code again that I just wrote, and yeah. But basically, you can go ahead and play around with that if you want with the website. That will be online for a few more weeks, and you can just play around with the users there. Maybe try if you can send messages to other people here, and then if you have any questions about the encryption part and you want to play around with some stuff of that, you can just come to me and ask. Yeah, that's it. Any questions about something? No.
Okay. I just wanted to ask if this is just like the highest level API Mac has, or because it seems like there's a lot of foot guns, like, oh, you need to verify this key and do this in the right order. And
no, as I said, this is from scratch. So this is the lowest API that you can reasonably be expected to use. Like if you want to, usually if you want a higher level API, you use the Rust crypto crate or something, which does, you just say it, I want to send a message to that user, and it does everything in the background. But because I wanted to show how that works under the hood, that's basically what the Rust crypto crate would have to do.
Right.
So the only thing that this actually builds up on is libolm or something, which just implements the ratcheting of the stuff here.
Right, the crypto primitives stuff. Yeah, okay.
Could you maybe elaborate once again? So we have macOlm and Olm.
Yeah.
When do we in practice use what? And maybe as someone who's not a programmer, summarize what's the exact difference between those two, apart the fact that one is using double ratchet and the other one is using single ratchet.
So the Olm stuff we use to send messages between the devices, which you could see here with the send to device. This you can only send to a specific device of a specific user, like one element session that you have, for example. This is because this is, uses the identity keys of that specific device every time. And so you need to encrypt for every device this message. And it doesn't really scale to a room with a few thousand users, for example. So then you use that only to transfer the keys, the macOlm keys, which and macOlm is then used for the room messages, because that's just very cheap asymmetric encryption, and you already assume just you shared the key to everyone, and so you can just encrypt the message really quickly, and you don't need to share the key unless someone new joins the room, and then you just need to share it to that person. Now you actually need to share the key a bit more often, because you don't want to reuse that key indefinitely, so you rotate it after 100 users, or after 7 days usually. So you actually need to send out quite a few Olm messages with the macOlm key specifically, so it doesn't scale that well. And if you have many users, the first message you send after 7 days, you will notice this will takes a long time, and then after that, the next message will be quick. And that's because it first it creates a macOlm session which goes instantly, and then it needs to send the Olm messages to every user, one for each user. And then after they have all the keys, then actually the message is sent out.
Thank you.
This is probably stupid, but over which channel is the device keys sent? Like, they're not sent in the room, correct?
No, they are actually uploaded to the server, and then you use the server API to download it.
So you query the other servers, like other participant servers. I query their servers as well? Or do I query them through my home server?
Yeah, basically you upload it to your server, which has then a special endpoint for the clients and over federation to query the keys. There's some federation talk that announces, okay, the keys might have changed and you might want to requery it on the other side. But yeah, that's basically what was this part here with the... if you look at it here, this query keys, this is just an API call to underscore matrix / keys / query, and that will then give you all the keys for the users that you said you wanted to have the keys for.
So I only talk to my own server.
Yeah, you talk to your own server, and then if the key doesn't, if your server doesn't have the keys for a different user on a different server, it will then send a message over federation to query those keys, and once it has those keys, then it will return the response to you.
All right.
Sorry, so just for clarification, in case I would join a room with 10,000 participants and I turn on end-to-end encryption, at least to start a macOlm session, I would need to send from my local device 1,000 different messages to the two-device endpoint?
No, because you can actually send all the messages at once to the two-device endpoint, because as you saw it has this map here. Okay. That's, of course, the code that I deleted by accident. But if you look at send to, or maybe it's easier to have it here. Send to device. If if you look at this, you just specify the event ID, but it doesn't have here the user that you're sending it to. This is actually all in the body, and it's just a map from the user ID to the device ID to then the actual message that you're sending. So you can just send it to Alice and to Bob at the same time by just putting both of those keys in the map there. And you also put all the device IDs there. If it's too large, that request, it might fail, so you usually want to chunk it a bit so that your home server doesn't get overwhelmed with that. But yeah, you can send multiple messages there at the same time. But you need to encrypt each of those messages individually. So you need to have to query all those keys, and that takes a long time.
So the biggest load here is actually on the client side to generate this request locally to then send it to the home server.
Like for the home server, it doesn't really make that much of a difference, because if you send a message into the room, it already needs to send forward this message to everyone, other server in the room. So if you then do the same for the two device messages, it's just a bigger payload, and it needs to split it up, but it still needs to send one request to every server in the room. So it's pretty similar.
Got it. Thank you.
Do you know what SSSS is?
Yeah.
And can you explain it?
Well, it's just symmetric backup where you can store stuff on the server, encrypt it with some key that hopefully nobody knows, and then decrypt it again. So it's basically a generic storage on the server side. The key that you actually use for that is you might have that recovery passphrase. This is the base 58 encoded AES key, I think, that you use for encryption. Or you might have a passphrase which then just does some key derivation to then generate the AES key. And you can store arbitrary stuff in there. Usually you store the private part of your cross-signing keys in there, the private part of your key backup key, but you can also store other stuff in it. It's just stored. In the end, it all maps to account data, and the SSSS part stuff is just how that account data is encrypted.
Okay, so it is matrix specific. It's not a general crypto thing.
Yeah, it's just like if you look at the...
So you actually store your private keys on your server?
Yes, but they are encrypted, so you can
with your recovery passphrase or whatever.
That's
right. Yeah.
That's also why most clients don't allow you to use a passphrase anymore for your online backup, because many people use the same passphrase as they use for the login. And every time you log in, you send your password in plain text to the server. So if it's the same as your recovery backup password, then obviously the server can read all your messages.
Right. Also encrypted with a passphrase probably doesn't sit well with a lot of crypto people.
Yeah, it depends, because that depends on your client, which like it's the same encryption that something like LastPass or Bitwarden uses. That also you have a passphrase, then it uses that to generate an AES key, and then it encrypts the stuff with that. So it's as secure as something like that. But of course, it depends, as we noticed recently, if you have been following along, that there was a security where they had the rounds that they used to derive the key were too low. So they, it wasn't actually secure because you could crack it relatively quickly. And if you just use a recovery key, since that is just the base 58 encoded AES key, there's no way to make it more secure than that.
Okay. So Matrix is a password manager. Got it.
Well, yeah, actually, if you want to download the Neko nightlies, you can also use the media repo as some storage for any big files that you want. So I just
it's an object store and a password manager, but it's no longer its own auth implementation.
Yes.
I love it.
Also something you mentioned before with the key queries, there's something that also tends to happen quite often, is that your Synapse server doesn't know that the identity keys or the device keys on the other side have changed. So yeah, that's also something how often the encryption fails when you play it in the backup into your server, because it doesn't notify the other servers that the device keys changed. So the clients don't know that they need to send out the keys to more devices because they never got a notification for that. And since rooms are eventually consistent, because if you notice you're missing a previous event, then you just fetch them. But that doesn't apply to your device keys and device list, because they use a completely separate channel. So if you don't know about that they changed, then your end-to-end encryption will be broken, and you don't really know how to fix it, apart from hitting the refresh key list button a few times and hoping that the server doesn't serve you a caged result every time, but actually tries to fetch it again. No more weird questions? Then we are done, I think.
A mystic spiral in the house. Mystic spiral, turn the music down. So, ladies and gentlemen, gentlemen and ladies, in real time, a bit late, but still on the schedule, we now will have another interesting talk. It is about matrix real-time communication. It will be done by Timo, the author of the awesome The Board. Maybe some of you know that. It was one of the, me personally, most impressing projects when I was digging into the world of beyond chat matrix applications. Yeah, Timo, welcome at Seabase. The stage is yours. Take it over. Oh, the sender is malfunctioning. So this is the first real-time communication problem we have. It's not matrix-based. I think so. That's the reason. It's like in the real world. Alles eine Frage der richtigen Einstellung. Yeah, should I pass just mine over?
War gemutet. Ja, das scheint zu tun. Okay, perfekt. Ja, wenn du das machen kannst, wäre richtig gut. Gott sei Dank nicht. Manchmal, mal so, mal so. Okay. Perfect. Cool. So, after you guys having the chance watching me dress up for the talk, I'm finally ready. So, as Jan already introduced, I'll talk about matrix RTC and element call, but it turned out it will be mostly matrix RTC. Oh, like this? Is that better? Thanks. It will be mostly matrix RTC and just a tiny little bit of element call. And I put it the subtitle, The Journey to a Stable, Scalable, Flexible, Real-Time Communication Platform on Matrix. So even though we are basically mainly working on building element call, we're also trying to make it a very stable foundation for any kind of real-time application you want to build on top of Matrix. And before we go into too much technical things, I want to talk about something a couple of years back, and that is how the Greek gods communicated. At least how they communicated when their usual system of delivery was out of order. So what they did is they had a chalkboard on the Olymp, and then whenever there was an occasion where they wanted to communicate something, they just choose a random human being and force that human being to run to the Olymp and write a message on the chalkboard. And that sounds like a pretty feasible idea, but what they ended up with were a lot of problems. So one was if two people kind of simultaneously wanted to, for instance, schedule a meeting and with each other, and then they both sent humans. One took longer, one a little shorter. And even though they checked what the board said before, they ended up overriding their own messages. And then, yeah, that was super annoying. And another problem sometimes occurred that they wanted to do a meeting for the whole fellowship. And then one person came up with the idea and another one, for example, Zeus and Hera. And they announced a meeting, one outside, the other one inside. And then the first messenger arrived, wrote inside, a couple of people checked, went inside for the meeting. And then the other messenger arrived, updated it because of the latency. And then the last people who were joining a little later went outside because that's what the board now said. So even though that sounded good, it caused a lot of issues. And now we look at the almighty Goddish chalkboard and see what is up for today's agenda. So basically, I'm stopping with the whole Greek thing for now, and this was just for the beginning in case you're worrying. So we first talk about the original group calling, which is what Matthew also had in his talk, the MSC 3401, and why we made changes to it. So basically, there are a couple of implementations on it, and even element call was implemented on it. And I'll just talk you through so we're all on the same page, and then see what changes we wanted to do. And then basically, most of the changes are LiveKit, and I'll just talk you through what that exactly means and how that is entangled with the rest of the calling architecture. And then the third part will be about our new architecture, or the new structure. And we call this matrix RTC because it's somewhat detached from specific calling. That was the case from the beginning, but it's now even more. And we just show how we implement the findings and changes. And then kind of the elephant in the room with the whole, we switched to LiveKit. Is this now like a full marriage, Matrix and LiveKit, which would be amazing because like they're a very similar project. They are all like open protocols which everybody can use and everybody can empower things with. But it might also raise concerns because that would imply we always have single forwarding units and you have to host a server. So basically, can we get full mesh back again, which was the initial idea of the whole thing. And then at the end, I'll do one slide about element call just to see where we're at with element call. So full mesh calls. So basically, I did a little diagram. Just a little overview. So basically in the bottom, we have everything client-side related. At the top, we have the server components. And on the server, we have the very prominent call event. So whenever you want to create a real-time communication session, you create call event, which is just a state event containing all the information like title and other related things. And then we have the membership events, which are one event per participant where all the call member-specific information is stored, so everybody has an overview. And then, at the bottom, we have those green bars as communication channels over matrix, core matrix communication things. So those are two device messages, and those are just CS API calls, and we have the WebRTC connection. So I now want to just walk you through how a call setup or a call lifecycle would look like. In the first step, one of the users who's interested in having a call is just posting a call event. So the big event at the top is created, and the call is open. And then people start to see, there's a call event, I want to participate, and they send their member events. And with the help of those member events, people can figure out whom they want to connect to. And the actual connection between the clients, because we are in a full mesh world, is then done over a WebRTC channel, but therefore we have to negotiate candidates. That's just a thing. Like if you want to do the WebRTC channel, you just have to do some negotiation to figure out how exactly that WebRTC connection should look like. And that is done over 2 device messages. So basically we go through this process. There's more details, but don't want to go into too much detail there today. And then at some point in time, they decide one person is pushing a matrix, a WebRTC connection to the other client, and then there is an established connection, and we have a option to exchange real-time media data. And then as soon as, I guess you saw the diagram long enough, so I can just continue talking. So as soon as the one of the participants decides that this call is over now, they just update the call event at the top and put it, should I try to reconnect? Could that be of help? We'll just wait. So they update the call event, put it into a terminate state, and oh, this was literally just my computer dying. Oh, thanks. Yeah, that wouldn't have recovered. So they set the call event to terminated, and everybody disconnects. So this was basically the theory, and then after implementing it and playing around with it, we ran in a couple of issues. So the first one is we have a single WebRTC connection, and we don't really have ownership of this WebRTC connection, and that's kind of why I did the whole Greek gods beginning example. That's very similar to our chalkboard. If we don't have ownership of the chalkboard, if all gods use the same thing, they can override their own claims or each other claims. And in the WebRTC situation, this looks like that we have so-called SDP candidates. So the signaling description protocol, I think it's what it's called. I noted it down, might be wrong. So basically, if two people want to change how the signaling looks like, or how the connection looks like, for example, both people want to start a screen sharing, then they both update the SDP, but one will be the quicker one, and then they override each other. So basically, you can end up in a situation where we both want to screen share, but one of us just cannot because we get overwritten. So what the solution for this is that you have two connections, one where person A is sending to person B, and the other one where person B is sending to person A. But that would incline a pretty big refactor. At the same time, we also had lots of unable to decrypts. Like that was a time in Matrix where the unable to decrypt state was not too stable before the Rust SDKs, and that also made it super tough because then this process was very, very unstable. So we also sometimes didn't end up with an RTC connection in the first place. And we also didn't really have a recovery system because the way those candidates work is that you first go back and forth, and then you push your stream to the other side, and then you have an established connection. But there's not really a way to say, oh, I think I'm missing a stream from this member event, so let's just pull those streams from the other participant. And that basically all ended up in a what we call split brain situation. So different people were seeing different versions of the call, and nobody was really happy. So same as the gods, we also had like a non-too pleasant experience. And on top of all this, our actual goal wasn't to like debug the whole MSC 341 situation. What we wanted to do is getting larger conferences. That was our main goal. So that all kind of was a little bit annoying. And then the more we researched, we saw we are actually also not really solving new problems. Like the more we investigated, the more it looked like we would rebuild something very similar to LiveKit. And just to see how similar our plans were with LiveKit, what LiveKit already delivers, I prepared this slide. So on the left-hand side, it's the exact same list from before. And on the right-hand side, we see what LiveKit is doing. So LiveKit, just as a quick summary, is just a wrapper around WebRTC with an SFU. So they kind of put abstractions on top of the core communication things, and basically those abstractions are very clean and they remove all the pitfalls you could run into when doing it yourself. And that's also the goal with Matrix RTC, that we kind of want to have a system where all the pitfalls are taken care of and you can just have something that works. So our single WebRTC connection and the ownership problem, LiveKit uses two WebRTC connections between the SFU and you from like in their design. Then the two devices unable to decrypt situation also is kind of solved because LiveKit uses a WebSocket connection to connect between you and the SFU. And then no recovery system, and the pulling streams also wasn't available. They have a very proven protocol which is taking care of almost all the edge cases one could think of. I mean, I don't know, but I see that it's very stable, and that makes me expect that they take care of most of the edge cases. Probably there are some edge cases which are so specific that even they didn't take care of yet. And then our goal is to work on larger conferences, is that LiveKit also ships a fully built open source SFU. So that was a very great fit. The only thing which kind of was concerning is that our signaling, which went over two devices before and they are encrypted, now uses something entirely unrelated to Matrix, the WebSockets connection. But if you think about it, as soon as you have an SFU in place, and that SFU is responsible for negotiating the WebRTC streams, then you basically, by design, need the SFU to, we'll recover quickly, need to know about what kind of signaling messages you're sending to the SFU. There's no way around it, because if they are encrypted on the SFU, then the SFU can't really do anything with it. So basically, this metadata leak will always be the case if you use an SFU. And therefore, it also doesn't really matter if it's like matrix-specific communication protocol or WebSockets. So it doesn't look pretty on first sight, but it's basically a given that we have to do it like this. So then we kind of had this whole LiveKit vision, and now the question was, how do we implement LiveKit in our current infrastructure? How can we make as little changes as possible and still ship LiveKit fairly quickly? And our solution was to just put the LiveKit URL into the call event. Because our call event, if you remember, that's the one thing you create for having one central information point about the call. And in there, we put the LiveKit URL, so everybody knows, and the alias, so basically the URL and the alias, it's like the whole LiveKit information blob. So we know the memberships, then we can just check out this URL, know where to connect to, know the alias of the room, and then we'll have this separate network, basically, with the LiveKit SFU where all the clients connect to. And they'll all end up in the same room, because the LiveKit URL contains this information, and that's part of the room state, and all members are hopefully part of the room state. And there's another cool thing which we could leverage from Matrix, and that is this LiveKit SFU, so it can't be abused by other projects just using your resources, has an authentication system over OpenID tokens. And those are not the OIDC thing Matthew presented this morning. Those are like a pretty old system, which we also used for Jitsi, where you can just ask the home server to give you a token, so you can prove that you're from this home server. And we could directly reuse the setup, which is really old, and in the CS API, to basically authenticate with the LiveKit SFU. So that was a very quick implementation, and it worked fairly decent, until it started to also cause some issues. And this is basically the same figure of the one I showed before. But here I'm presenting one specific failure mode. So basically, if we are listening to changes on the LiveKit SFU, and this doesn't sound necessary on first sight, but if you have a call event and then something changes, basically your host of the LiveKit SFU changes their domain, for whatever reason, or they have to do a redeployment and change something in the LiveKit URL, then you, of course, have to kind of also update the calls to now use this new LiveKit instance. So we kind of build in a system so the clients can bring their LiveKit URL, and if there's a new version of element call, they could bring a new version and then update the call event. But this kind of allowed for attack surface, or also failure mode, whatever you want to look at it, that if we have one confused client or evil client or non-updated client, and the call was working with the two clients on the left-hand side, and then this client was joining, updating the LiveKit URL with something broken because old configuration or just being evil, then you basically ruin the experience for everyone, because then people listen to the update, they try to connect to the new LiveKit URL, and nothing works anymore. And to sum up, one can say one broken or malicious client can break it for everyone. And that's something which we figured out we always have to keep in mind. That's like very, very bad, especially in a distributed system. Like if one person can mess it up for everyone, that's a really bad design for a distributed system. And there's another failure mode. Basically, if you don't listen to the changes and you just say, well, we just take whatever is in the call event on connection, and then we just keep this, because then we cannot run into connecting to something broken, then you still can have the a split brain-like experience where the first client is connecting with the right LiveKit URL, then the second client, the confused client, like those indices right here, they are basically the order of connection, is connecting, updating the LiveKit URL to something broken, and then the third client, who is not broken, but just something different, and then the third client is connecting, and we end up in two LiveKit instances. And that's also a failure mode. So what did we do? We basically noticed that we don't need the call event. Like, it's enough if we just have the call member events. And then we kind of mitigate this Greek god situation where they have one chalkboard and they kind of all have ownership over this chalkboard and everything gets messy. Instead, they all have basically their individual chalkboards, which are the call member events now. And we compute the actual call event. So here we have the new structure. Now the server just has call member events, no call event itself anymore. And on the client side, we have a computation function which takes all the member events, the array of members, and then computes a call event, kind of. And that is really good because we now don't have an ownership, or we have a proper, clear ownership model where one client has one call member event which can only be changed by this one client and nobody else. And this computed event also gives us some good features because for once, the call event is not necessary anymore. And for glaring situations where we are not sure what the actual truth is or where people are in like different states and there is a conflict which needs to be figured out, we can make this very transparent in our call event. So for instance, we could either say, so everybody is now containing the LiveKit URL which they're connected to because the call event isn't there anymore. Basically, all the call event data is now in the call member events. And we could either say we just take the SFU from the first one who joined. And then the first one who joined can be determined by the timestamp of the events. And then this is a glaring algorithm which always converges to the same event. Or another situation could be that we just have one admin in the room and we just say we'll always use whatever the admin is having. Or we can somewhat implement a democratic approach, which could be a little bit more messy, where we say if there's like a significant mass using solution A, then we all go to solution A if we join to this whole thing. So basically, we can application dependent, we can basically choose whatever is the best for our use case. And just to walk through a failure mode now, so if we have a confused client again, this client messes up his or her call event and is connected to the wrong FOKI or the wrong LiveKit single forwarding unit. But it doesn't break the experience for everyone. It's just this one specific member who is then having issues. And that's a much more stable and sophisticated situation we are in, where it's much easier to move forward. So basically, this moves the whole matrix situation from what we had before, on the left-hand side, one call event, members attached, to a new world where it's just a room is basically always in the state where it could be a RTC session. In a room, people just go ahead, put their member events in there, and then that's an RTC session. And there can, of course, still be multiple sub-rooms or multiple meshes by just claiming, I'm a call member, but I want to do this kind of thing. I want to do a computer game, a real-time computer game, and the other one is saying, I want to do a video chat, and it all works, even though there's no call event they attach to. And the next step I want to do in this presentation is to have a closer look at what this call member event looks like. So on the right-hand side, this is our new solution, just a very flat structure, call member events, and that's it. And this is how they are structured. So we have a content event, like every state event, and in there we have an array of memberships. Because of course it can also be possible that one user is connected to multiple sessions in one room. In this case, there's only one membership. And at the top, we have everything that is actually matrix RTC specific. And those are the things which are really needed to connect to each other. So we have a device ID, an expires time, which is we can talk about this later if you're interested, but not too important for now. And then we have the FOKI active part. That is very important because that contains all the information which is required to connect to this specific member. And then at the end, we have the application key. And this makes it possible that we can have multiple applications for different membership events. And at the bottom, there's application-specific data. So this is also kind of new, that basically with the value of application, you define whatever values there are in this member event. And that also makes it super flexible, because now the application itself is empowered to maybe add additional informations. So for calling, we figured that it's very important to maybe also have a call ID. So we can have 2 calls in one room, and each call would have a different call ID. Then we figured out a concept for scopes, which is also interesting, but won't be covered in detail in this talk. So that's just configuration for this one specific application. And those are grayed out because they're currently not in use, but discussions about it happened. And I think even Matthew hinted it in his talk this morning, that we might use room events for the whole ringing and, for the whole ringing infrastructure. And that could also be thought of. So basically one person is sending a room event and then a membership event linked to this one room event, and then people receiving this room event, the client can react by ringing and then also create a member event to this linked event. So they all know they are in the same call. And we can even think about, that's not call specific, that's just some random shared or individual data. And with the glaring algorithm, we can then decide what I want to have as my shared or individual data. And that's all application specific. And here, I just made a very broad example. So we're going now really far away from calling. So if we imagine something like third room, we could even do a first step optimization where we just have in the shared data field, we have somewhat the chunk ID, for example, or the space ID of a specific user in one huge room. And then you can filter, before even doing any WebRTC connections, filter out a bunch of users which are not interesting for you because they are so far away or in different rooms. And you only connect on a huge world with the ones which are in a similar chunk than you. So there are like lots of things you can do with this, but all application specific. So now to the big topic, the revival of full mesh. So basically, if we just go back like this, active foci, in this slide, I just said this is how you connect to the user. This can actually be something, so this has a type and can be something which just makes sense. So basically, what we want to do is that this foci, or like LiveKit at the moment, is interchangeable. So it's not part of the matrix RTC spec per se. That's also all up for discussion, of course, but our current plan is that this is not part of matrix RTC period, but it's something that is another component which is also interchangeable. And basically, you can think of this active foci as the route or method to connect to a specific member, and there can be different infrastructures for this. And of course, LiveKit is our basically prime example at the moment, but full mesh could be revived as another infrastructure for matrix RTC. And here I have a list of the requirements a infrastructure has to provide, and that's just a procedure to request a stream from any of the members with the information in this field. Then it has to be possible to send a stream, push a stream with the information of the active foci to a specific member. And then basically the counterparts, like reacting to those requests and pull and push requests. So if somebody's pulling from me, I need to have a procedure how to react to this and provide the stream. And if somebody's pushing a stream onto me, I have to have a procedure how to accept the stream. And that is basically what the infrastructure component needs to provide. And LiveKit provides this with the WebSocket API. And we could and would like to, and let's see what the next steps are, could also imagine that this is totally feasible to basically do with full mesh as well. So we would do some changes because we think the two-stream solution is very, very good for not having ownership of, like not have shared ownership of this one connection. And we really would like to have the requesting stream and providing stream implementation so we can also recover and pull streams if we somehow messed up the situation. But then there's no real reason why full mesh shouldn't be also a possible infrastructure. So basically to now give the full picture how this all evolved and what the current plans are, is that we have those three kind of specification layers. So we have matrix RTC, and this is just how the state event looks like. So what we looked in at the beginning, like we don't have the state event for the call event anymore, we just have member events, and the member events have a section for app-specific parts, and they have a section for the matrix RTC-specific parts. And then we have app-specific specifications. So m.call could just be a general call specification, which has all the features a call has. Or we could also do something m.element call, which then might have, or io.element.call, which might have element call specific features inside the app specific section. Or if you want to do a race game over matrix RTC or third room, then this would be an app specific specification. So you can also have different clients for a implementation, especially for mcall. It's totally feasible that you want to have not just element call, but different clients. And then the last piece is the infrastructure. And this is what we have at the bottom, which can be either LiveKit or full mesh, or maybe there's something much, much better in the future. So basically, we want to have it kind of similar to what we have in Matrix with encryption, where this is also a replaceable component. So if there's something new, which is just much better than LiveKit, it's not enforced that we have LiveKit. It's just if the people say, connect to me with LiveKit, then you do so. But if they say, connect to me with this new amazing technology, then you do it with the new amazing technology. Or the question we had this morning with what do we do in a peer-to-peer world? Maybe there's an amazing solution in the peer-to-peer world. Then there could be an infrastructure for peer-to-peer. And yeah, so basically that also makes it possible to have the infrastructure can then also have an entirely independent communication system like we have with WebSocket for LiveKit or two-device messages. And just to bring this again into the connection with the call events, like the call member events, I just put boxes around the different sections. So we just talked about matrix RTC, app-specific specification and the infrastructure, and this is what we can see here on the right-hand side. So the matrix RTC block is basically just those 4 fields. Then the infrastructure is whatever we have in Foki active, and there's no reason why there shouldn't be 2 different infrastructures happening at the same time. Like there can be full mesh and LiveKit at the same time. It just would be 2 fields in this array. That's also why it's an array. And then we have the application specific things, which is just a basically unlimited size, whatever the application decide is necessary for them to work properly. So that's all about the matrix RTC part. And we'll now just have a quick look at element call. I'm super glad I don't have to do demos anymore, because I'm really not used to do demos on stage, and Matthew is, so that's really lucky for me. But I want to talk a little bit about the encryption, because the encryption was kind of a very cool story, how all the stars aligned, where we had Firefox shipping insertable streams, and LiveKit adding support for encryption, not only just single shared key encryption, but also per sender encryption, and we reaching the place where we really have resources and like all the matrix RTC foundation things are solved, and we had the resource to also look into encryption. And it's also interesting that we have those 2 different encryption systems. So what Matthew showed this morning, where we have 1 encryption key for all the members in a room. That is what we use for the single page application. And there this also makes a lot of sense, because we don't have a trust or authentication model in the single page application. You just share a link and then join. And in this case, we are kind of reliant on the key sharing to also happen through a separate network. So you could use Matrix, send the link over Matrix, and then the key sharing also happens over Matrix. But you also could use an encrypted email or a non-encrypted calendar, which kind of would defeat the whole thing with the encryption, but whatever. All this is basically up to the user to make this key sharing secure. And there's nothing we really can do about this. So 1 key makes a lot of sense for those open rooms where you just join with a link. But if we look at the per device keys, that is really good for embedded mode. So if you have a already existing room, maybe just 2 people or 5 people, and you want to have an encrypted call in this room, then element call actually, or this LiveKit matrix RTC combination is a very, very good solution, because what we then have is that we have authenticated users, which we know, and we even go and they have a good key sharing system and everybody has a key. And it even goes 1 step further, that Matrix offers this amazing verification system. So they're not only authenticated, but each device is also verified. So you can be sure that all devices in this room, like only devices which you actually trust, have the keys. And then we can use those keys for per sender encryption. And then we have a very, very, very secure real-time chat system or video conferencing system. I'm not even sure if there's anything else on the market which offers a verification system with emojis or QR codes and then has per device standard keys. The only thing I found is that often they use single sign-on procedures, which is basically the industry standard in secure video conferences. But with the device verification, this is like very, very cool. And what we also achieved is implementing this whole new stack of Matrix RTC and Element Call. That also just happened with the release on Wednesday. So basically, those are the two new news from Wednesday. And yeah, I guess this also sums up my talk. Thanks for listening. And of course, still feel free to play around with call.element.io if you haven't already. And yeah, thanks. Oh, nice. So any questions? Oh, wait, before the questions. So I just had like a little extra note here. So for once, I'm super excited what will be possible to be built on top of Matrix RTC. I mean, we have Third Room. That's probably the coolest thing you could imagine and is already there. It's sadly still using the older version without the LiveKit SFU and also is kind of on hold. But Nordic also has built something really cool with a RTC solution, also still on the old thing, and I'm like, myself, I'm really interested in their talk and also invite, I mean, I can't really invite you, but I recommend watching the talk, I guess. Okay, then you're open for questions.
Thank you, Timo. Questions, yes.
First of all, thanks. Could you maybe explain very briefly again why the call members event is not affected by malicious manipulation compared to the normal call event?
So basically, you're talking about this slide, right? Where
yes.
Okay, so if we look back to the call event situation, there I kind of try to indicate this with the two arrows. So each connection to the call event was a write-read relation. Like every client had a write-read relation with the call event. And that is basically the main thing which made it very vulnerable. So if I'm joining and I decide I want to basically mess around with the current conference, the easiest that I could do is just put this on terminate or do something with this call event. Of course, there could be some permission system that this is not that easy, but it's still an option if not properly set up. And in this new system where you have the call member events, I'm not sure if you are familiar with the concept that if you put the key as your matrix ID, then you basically have ownership of this state event. So nobody else has write access to the state event. And this is what we use for the call member events. So in my call member event, the key of the member, or the state key, I think that's what it's called precisely, will be my matrix ID. And then nobody else can change this member event except me.
Okay, so every participant has its own call member event.
Yes.
Okay, it's not shared. Okay, got it now.
Oh, thanks. This is really good for me to repeat if I didn't make that clear. So basically, if we have 3 clients, then we have also 3 member events. And that's why we have 1 member event per client, and that's where the ownership comes from. Thanks for the question.
How do you deal with the ownership event if one user with one matrix ID uses multiple clients then?
In this case, it would still be the same member event, and just the array of memberships would be much bigger. So basically, of course, that's an issue. So basically, you can mess up your own. So if you have one client and you have another client, then you could basically hack the session of this one client. So maybe this client A is doing Third Room, client B is doing a video conference. Then the Third Room client has the potential to mess up with your Foki active of your call. That's a problem, but I guess that's your own fault then. So
at least it's just you who's affected.
Yeah. So
okay,
it's
thank you.
your.
With the element call slide, you said something with per receiver encryption or per sender individual encryption, something.
Yes.
Which makes it super secure. Sounds great. Doesn't that reintroduce the scalability issues of basically full mesh?
So honestly, I think we didn't really do any like larger experiments with, like in the beginning when we have LiveKit deployed for the first time, we had done some scaling tests, but since the encryption implementation, I'm not sure if we did lots of scaling tests. Yeah.
Of course, you create a full mesh to exchange the individual sender keys, but compared to the media, this is just nothing. So that scales beyond the... So let's say for the full mesh, we would say it scales up to 5 to 8 participants, because then the network bandwidth is just saturated. But if you just need to exchange these individual sender keys, there are significantly less data to exchange. So that works.
Yeah, so basically for the SFU, it doesn't really make that big of a difference, because the SFU doesn't decrypt anyways. So it just gets 10 streams, 10 different encryption systems or encryption patterns, but the SFU doesn't care. It forwards those streams, and then you just have 10 corresponding keys, and you just decrypt all all individually. So it could have a performance hit on the client, however.
It could, yes. But if you, let's say, if you're running into basically the same limitation as you would have with Magome, then we could also rely on a smarter algorithm like MLS for distributing the keys here, and then you would have a log n effort rather than n square.
Yeah.
When this starts landing in production, or are there any mock-ups how this will probably be implemented in the Element clients? Like, for example, I don't know. I, for example, think Slack kind of nailed it with the huddles, like in a way how to do calls in like day-to-day stuff like that. Do you know how Element will implement Element call later in the clients?
Yeah, thanks for the question. This is actually also a pretty interesting story. So by design, Element call has two different backends. It has like the CS API backend and the widget API backend. And since the actual communication you need between Element call and the server is quite limited, it's basically just the exchange of the state events, and the rest is then happening between the SFU and Element call. It's not that hard to get this done over the widget API as well. So what we're doing is basically take Element call with the widget backend and then just embed it in the clients. So basically then the client is still taking care of the encryption part, which you don't need for state events, but if we have room events involved as well, and the authentication part and the login and everything, while Element call is just building up the WebRTC connections or WebRTC connections to LiveKit. And this is really cool because that also makes it possible to basically embed it into the new X clients fairly quickly. So what we also have been spending lots of time on is basically having the widget API implemented in the REST SDK so that clients using, so that's also something pretty cool, I think, which is still somewhat in the future, but not too far, is that if the REST SDK supports the widget API, then we might see a lot of more clients supporting the full widget API, with also sending room events and receiving room events, and things like Fractal, for example. I could imagine also could implement widgets. And then Element call is, since Element call is also taking care of the state, so basically you really only have to put an Element call into the room, and then you just have to do one check. Is there a membership event of type mcall with application type mcall? Then you just start up the widget and it will do everything. Like it will just see, oh, there's member events. What's the for key it's using? Oh, it's using LiveKit. So I know that I have to connect to LiveKit and it just works. So basically the burden of the client implementing a call, if they are willing to use Element call in a web view, is literally just checking if there are call events, call member events. If there are, show the web view, and it will take care of everything. And then, of course, you can go ahead and be like, oh, I also want to count how many member events there is and show in the header the amount of people who are in the call currently, even though the web view isn't started. But that's all sugar on top. If you just check if it's there, you add the iframe, then you basically have a client with working calls. And they even would be encrypted as soon as that's implemented. So it's all pretty cool.
and pretty low friction to get calls into other clients then.
Okay. In this case, you would be in need to have the permission set similar to send an mcall event as well as to alter the widget.
Yes.
So this would be probably then linked to not fail. So I cannot start a call, but I am not allowed to open a widget, for example, in the client.
I think you have to repeat the question. I'm not entirely sure if I...
Okay. So we have these m.call events, these new ones.
Yes.
And there's also an event type to alter widgets, right?
Okay, yeah. So basically the widget part is just for those kind of static widgets, which are like fully attached to the room. And what we usually do, I mean, that's one option. You could literally just go ahead and do this /add widget and then pass the element call URL with a couple of additional parameters. But what we do if we do something like a client pretending to have native call support is that we create a so-called virtual widget. So it never reaches the room state. It's just the client, whatever is in the room state, which is just the widget ID. And I think that's the only thing which is really, really important. Oh, and the URL, like the widget ID and the URL for the content of the iframe. We basically just generate those two values. And then we have a virtual widget. We just create the iframe with the URL. And then we pass the widget ID to the Rust SDK so it knows which iframe to target. And then you don't have to mess with the room state at all, which is also a little bit cleaner because then otherwise you would have other clients which don't support the full widget API, just parts of it, and they would still list the widget. So yeah, for calling, we now opted, at least for element X and element web, to have it as a virtual widget, and then you don't need permission for this. So you just need to give the permission, to give the widget permission for the state events, the required state events.
One very short last question. Those visual widgets, are they part of the spec? Or is it something element specific?
I'm pretty sure they are not part of the spec, but nothing widget related is part of the spec. It's all like a couple of parts of widgets are in MSCs. And then the rest is, so basically, but it's still like, it's two big sections. It's how to define a widget in a room and how to communicate with the widget with those actions. And the actions are mostly all in MSCs. And also how to set it into, but that's really old MSCs. Those are, to some extent, MSCs still in Google Docs, who define, or which define how to put a widget state event. But yeah, the virtual thing is just a hack without, I'm not even sure if this has to be specified, because it's basically just an implementation detail on the client, and the widget is still treated as a fully spec'd widget, basically, or MSC spec'd widget.
Got it. Thank you.
Cool.
How does this new state event work with power levels?
Say it again, with?
With power levels.
Oh, so basically, I think every state event type can be associated with a different power level. But for this one, it's not really important because it's always owned by one specific member. So it's actually a really good question, and I just noticed that I think about it properly for the first time. But I'm pretty sure it's also a non-issue because since you have one member event with one state key as the user ID, implies that you are just the only one being able to interact with that state event. And then if you want to have a call where some people are not allowed to participate, then this would need to be a specific kind of call that basically would need to be something like a breakout room. And then what would make sense in those kind of scenarios is just use the application-specific section and maybe also add, so that could be a breakout room, which is created by one specific user, and maybe you only accept breakout rooms from a user with a specific permission hierarchy level, and then this would list the amount, the users which are allowed in this breakout room. Those kind of things could be imagined, but just from a very technical point of view, that's actually also something I wanted to briefly add as a side note anyway, so thanks for bringing me to that subject now. From a very technical point of view, we also need to be somewhat defensive in how much of a security model we present to the user, because in reality, there is no real method. Like if you have one room, you can't really make security subrooms in this room, because the encryption keys are shared anyways. Like everybody has access to the encryption keys. And if you think that the SFU also isn't like a fully secure system, because somebody could be the owner of the SFU. So we should calculate with the option that some users just download everything that is streamed to the SFU. And of course, that's encrypted, so that's not a problem. But if you are part of the room and you can download everything which is shared through the SFU, then you can always decrypt the streams. So basically, if you really want to have a secure subsystem in the calls, then you kind of have to create a new room. There's no way around it. And that's also why this whole system doesn't really involve a permission system on a Synapse space, because it would basically communicate a false sense of security, because there's not, like, as soon as you don't have different encryption keys, there's no real separation between the streams. So that's why we opted to kind of don't put too much permission systems in this. The only thing that is really important is that nobody messes with your membership event, but that's handled by Synapse anyways because of the state key being your matrix ID. So hope that.
Yeah, thank you.
Yeah,
okay.
I think basically the idea is here to separate the moderation bits and pieces from the signaling or matrix RTC session bits and pieces. So in the old world, you had the mcall event and the mcall member events, and you could have different power levels attached to those. So maybe only some moderators or whatever could start a call and others could participate. Since we now just have the mcall member event, so everybody who can start a call can also participate and vice versa. And if you really want to have, if you really want to enforce moderation, you need to have a trusted SFU, and then you can, through using the power levels, give a moderator or an administrator an admin connection to the SFU, and then really enforce that streams are just sent to this and the other person. But this needs a trust relation to the SFU.
Yeah. Yeah. But that's still a really cool train of thought, which I think I also would like to add that, for example, if you remember what I talked about with the linked event, like the idea that ringing might work by posting a room event and then linking to this specific call, and not just a general room call, but like attached to this event. Of course, this room event could again be a ringing type or mcall start or, I don't know, creative idea. Any creative idea could fill in this name. You could, of course, set power levels for this start event. So then everybody could just join in this random room call, but nobody could actually place a proper call. And then if you have like a big company and you only want 2 people to be able to call everybody with like ringing, then you could put permission levels on those custom events. And that, of course, then, since it's all implementation detail now, that, of course, allows you to have like lots of good ideas to separate the permission system there for specific features.
What about just in general writing the state events? Like I'm surprised I can write by default a state event in a room. For instance, could I go into Synapse announce and then add state events with my prefix?
I think there's a permission level for writing state events in general, but most people are on that permission level. Or are they? No, not really. I think that's actually something you have to add. And I also know that for the embedded element call specifically, we also have a settings allow element call, like new element calls in this room. And what that does is basically setting the permission levels so that you're allowed to put the state event in there. Yeah, so basically it would be the member event would probably get a really low permission level, so most people can participate in a RTC session. So, yeah. I mean, there are some state events which are very low permission, for example, just like the general membership things and leaving. That's, of course, also in your permission reach, and we would just treat them similar to those kind of events, where it's like possible for everybody to post a leave event or a membership, a call membership. But that's definitely something that has to be like part of Synapse, and I think that already is part of Synapse, or we are hacking around it by putting the permissions level correctly. That's something, yeah, definitely a solution to it. I don't know how it currently looks like.
Thank you.
Any more questions? No, I don't see any fun.
Cool. Then that's it. Thank you so much for listening.
Thank you, Timo. There's a little announcement. We discovered some inconsistencies between the planning and the reality. This time not in terms of time schedule, this time in terms of T-shirt registration and materialization. So in case you ordered a T-shirt and you haven't received it yet, please search for Nadine. I think she's at the bar at the moment, and get your T-shirt, because we also would like to give out some of the spare shirts to people which like to have it. But before, we want to give them out, of course, to the people which already have ordered them. Thank you for your attention. And now we will come here to the already announced NeoBoard talk in, let's say, 5 minutes. Is it something like that? More 7-ish?
Yeah, I don't know what the exact time is, but the real-time track will continue shortly. Just please give me a couple minutes to get started and prepare.
Yeah, and Greg will tell us in the backstage about his journey within and with the Ansible community, moving from IRC and some other technology stacks into the matrix. And now, ladies and gentlemen and ladies, we're going to start into the next talk with the awesome Kim Brose, also known as Har Links. He asked me to ask you to do him and me a favor. You see the QR code on the screen? Please join this space. It's the space for this event, and you have to join this. And now, Kim, it's yours. The stage is yours. Oh no, I'm actually on the stage. The floor is yours.
Thank you, Jan. Thank you, everybody. I hope everybody made it to the space, because that way you will be able to easily discover this room, which you can also join by typing this room alias, but I guess using the space is a bit easier. And yeah, so welcome to this talk about the Neo board. And before I begin, I would like to ask you, has anybody heard about the Neo board? 1, 2, couple, 3, 4, perfect, 5. Who has heard and is using perhaps widgets in Matrix, in Element? Yeah, a couple more people. Anybody using widgets that aren't call widgets? Okay. So, yes, before I get started, I just mentioned please do join this room and get out your laptops to do so, because right now it's only possible to use this widget properly using the Element web or desktop clients. And yes, if you do join the room, you should be able to immediately see this NeoBoard widget, and you can follow on your own screens and perhaps interact later on. And while you do that, let me quickly introduce myself. My name is Kim Brose. I am currently a software engineer employed at Nordic. And personally, I've been interested and hosting Matrix myself since early 2017. I'm interested in lots of things, especially receiving notifications, connecting stuff with bots and things like that. So if you're interested in that as well, talk to me. You can find me on GitHub, and you can write at me using this Matrix ID for anything that concerns the Nordic side of things, the widget, and so on. We also have a public room to discuss this, which, yeah, we'll come back to that later. So you might have already noticed what's new at Nordic. We are here with a couple people. So you recognize some of them by these nice Nordic shirts, if you have any questions about these. Nordic is a German company, a Hamburg-based company that develops things based on Matrix, and especially so far our focus has been on widget development. If you have been to the first edition of the Matrix Community Summit, then you might have experienced Hato's talk last year about Matrix Element and widgets in the sovereign workplace for the German public sector. You might ask yourself, what's the sovereign workplace? That's a project that intends to create like a suite of really tightly connected different apps that fulfill the use cases of something like Microsoft Teams, and it's supposed to be or to become an open source and sovereign replacement for these kinds of US cloud-based suites such as MS Teams, just using open source software, and particularly those people funding these projects are, in the case of the Sovereign Workplace, which has now in the meantime been renamed to OpenDesk, is the Ministry for Inneres. I'm not sure what's the correct German translation. The Bundesministerium für das Innere. Interior. Ministry for the Interior, German ministry. And so what they find very important is to have this digital sovereignty, being able to host their own applications. By the way, if you're interested in the rest of this suite, we have these flyers, and of course, find us to talk about it later. We also have some stickers. Yeah, what happened since last year? Hartzo presented a couple of these widgets, and in the meantime, we managed to deliver and open source I think all the widgets that were presented here on this stage last year, they are licensed under Apache 2.0. And the other thing, while there was already some concept around having a whiteboard widget at that point as well, we also did a complete rewrite of this whiteboard using WebRTC to enable it for actual, real, instant, real-time communication. Yeah, some other things that have happened in the meantime as well is we have extended the widget API both by the spec and also the implementation that Element has with some features to enable, which we will see later on. We also extended the Element plugin system, the Element web plugin system, so we can include some custom functionality. And right now, one of the things we are working on is implementing knocking an element, which enables you to have some kind of a lobby. You can ask to join a room. Where's my cursor? There it is. Now, what's the NeoBoard? Apparently, only a few of you have already heard about it. In its core, it's a whiteboard, and it tends to be an alternative to some of these commercial tools out there. For example, you might have used a tool such as Miro. And like I said, it's part of this Open Desk application suite, which is to be used by the Ministry of the Interior in Germany. Importantly, I called it Matrix Native here. It's supposed to integrate with all of the components are supposed to integrate, but especially this whiteboard is supposed to fit into this real-time communication use case, which is why it is integrated into Matrix and the Element client. And I can show you this, or well, you can see this on yourself if you're following it on your own screens. This is embedded inside of a window inside of an Element client. That brings me to the topic to quickly summarize what's a widget. Widgets are web apps that can be embedded inside the Matrix client like this. And it enables the Messenger client to be extended for some special use cases. For example, we have heard from Timo about the Element Call technically being a widget if you integrate it into the Element web client. And there are some more use cases. Having a whiteboard is one of them. Well, I said they are web apps that are integrated inside of the same tab in your browser, basically. But it goes a bit beyond that. That makes it a widget instead of just a simple embedded frame. And that is, it can also connect and talk to the actual client that does embed it, which is, for example, how we can use Matrix to store the data that is contained in the NeoBoard. All this text is somehow encoded and stored in the room. We can use some other features, like, for example, if you look at the top right here, you can see all your faces who have joined me on in this widget. And yeah, that's all possible thanks to the widget API, which is able to fetch this information through the client from the Matrix server. It can reuse your accounts and all the nice features that come along with it. It can use the room, it can use all the permissions level, and so on. Now, it's important to point out that this is not a drawing tool for art or something. It's a working tool that's supposed to be used for things like brainstorming, drawing mind maps, creating concepts, and, well, perhaps giving presentations such as this one. Where's my notes? Yes, I just touched on this very, very slightly. Let me go back into full screen mode. I want to tell you a bit about this architecture. So you can see here we have this different levels of blue. And on the outside we have the browser. In the browser runs the element messenger. In there is an iframe. In the iframe runs this widget web app. And then we can see the widget API, which enables the app running inside of the iframe to talk to the element messenger, and they can exchange information that's already present in the element messenger. But if something perhaps isn't already synced, then it can also ask the element messenger for the data anyway, and then element will go and using the client server API will fetch this information from the home server if needed. Yeah, especially it's very nice because you don't need an extra authentication step. However, something you do get that separates this from your account a bit is a window of permissions. If you have joined, then you might have gotten this pop-up with all the permissions listed, and that might look a bit scary at first, so the UX perhaps can be improved. But actually, while seemingly overwhelming, it's actually pointing out all the things that you allow the widget to do, so in a way that makes it more secure. What can you do with this NeoBoard tool? Yes, compared to other similar tools, whiteboard tools, you might have already noticed that it has fixed-sized slides in a 16:9 aspect ratio. And this makes it easy and fitting for also giving presentations, but is a bit different from how other tools work. Things that you can do is using this toolbar at the bottom. You can draw certain shapes and lines and freehand. You can add text to things as well. You have obviously multiple slides. So there are multiple pages you can draw on, and there's this presentation mode that enables you to go from slide to slide. And very importantly, all of this works collaboratively, and that's what I want you to try out right now. So if you still haven't made it to the room, here's the room ID again. Please join, and I will now enable the editing mode for everyone, and you can play around a bit. But please stick to this slide and perhaps keep the header so everybody can still find the room alias. So yeah, we have this lock and unlock feature. We have the other presentation feature of going back and forth. We can already see some shapes appearing, lots of shapes. We also have this eye up the top here, and this enables us to show all of your cursors. So we can watch who is editing what. Wow, there are certainly a lot of people on here. Very importantly, everything of this is based on Matrix. There's no additional backend, and we can have other nice features such as the end-to-end encryption that just natively ships with Matrix, all the authentication already in Matrix, and yes, this all reused because we use this widget API. And you might notice all the movement, even though there's a lot going on, really. Still, it's shown pretty fluidly. So somehow we managed to make it work in real time. And I don't know if two people have already tried to edit the same object, but certainly you have edited the same slide. So clearly this works in a collaborative way. We also have some more features. For example, if I find my own cursor even. Yeah, I can also draw stuff. Here's a triangle. I can undo it, and it won't interfere with whatever you are doing. So I think I'm going to pause it here so we can continue. Thank you for participating. How do we make it work? like I said, this is all based on matrix. And if I go back and get to the timeline and I get some enable viewing hidden events, then we can see there are lots of hidden events in here, and I can't read them right now. I'm trying to grab a Neo board event. Wow. Perhaps it's this one. Yes, you can see these are all hidden events. And events in Matrix, if you are not too familiar with the technical side, events are just JSON objects. They have, most importantly, a type. They have a sender associated with them, and they have a body that conveys the information you as the user want to convey. And that could be just a regular text message, and in that case, the body is just whatever you typed in the chat. But we can also use these kinds of custom events, and in them we can store any kind of data we want. For example, we have these chunk events. Maybe I managed to find one. No, maybe not. Can you help me find one? Anyway, maybe you find your own. These chunk events are what actually contain all the data, and if you look at them, you will find that because the whiteboard data uses a binary format, we base64 encode them, so it's possible to store them in JSON and then dump these into these chunk messages. And we send those to the room every 5 to 10 seconds or so with a full snapshot of all the whiteboard, including all the slides, all contents. This isn't exactly real time, you might notice, but we are limited in this way because the Matrix servers, especially the Synapse server, which we use, come with a rate limit. And this rate limit limits us to sending an event every 10 seconds or so. Well, because at some point the neoboard grows so large, we need to send multiple events. That limits us quite a bit. And at the same time, we want to stay compatible with more or less the default configuration of the home servers. So yeah, that's a limit right there. So how did we solve this? Let me go back to the full screen presentation. On the next slide, we can see we added 2 layers, one on the top and one at the bottom. And so the first thing we do is we use the local storage in your browser to instantly save anything you do. And that is because if you quit, or maybe you switch the room, maybe you close the tab, maybe your computer is out of battery and shuts off, and it had not been sent into the matrix yet, then the data would be lost. And because we don't want you to lose what you just worked on, we have to save it immediately, and then whenever you come back, it will be merged back into everything that has happened in the meantime, and you can continue working where you left off. And the perhaps more interesting part might be the real-time component. So we solved being able to communicate more or less as fast as we want using a WebRTC connection. And has anyone here worked with WebRTC yet? Right? No, not so many people. Mostly the Element Core guys, right? Yes, well, so what WebRTC is, in essence, is a browser standard for real-time communication channels. And that allows us to connect everybody's browser to each other and exchange as much data as we want. Much similar like a call, you might imagine, but instead of sending your voice and video, we send these neoboard update chunks and deltas. And However, what WebRTC doesn't solve is the signaling part, so establishing a connection. And we did, of course, solve this as well. You might imagine how we did it, and perhaps Timo already scratched on that. The signaling layer is not standardized in WebRTC, so, well, of course, we use Matrix. Very much similar to element call. This is currently mostly based on this original MSC 3401, because right now all this nice Matrix RTC we have heard about, or well, at least at the point where we built it, it wasn't available for us to use it yet, so we implemented it in our own way. We use these two device messengers to negotiate. We have all heard about that just in the talk before. We do a full mesh connection, and that works all right, because compared to all this voice and video in an actual video conference, it's not that much data. It's just too much data to post as chat messages. And yeah, maybe Matrix RTC at some point becomes available to use as a library, as an abstraction that's basically WebRTC standardized for Matrix. And at that point, maybe it's even possible for us to switch to it. There might be an SDK, and we also gain all their nice features, like perhaps SFU support, so we don't even need to use full mesh anymore. The other thing we needed to solve was, of course, how to collaborate on a document. And well, how do you ensure that there are no editing conflicts? Maybe you edit the same thing, the work of someone else might disappear, you override it. There's a lot of potential for conflicts, I guess you can imagine. And so what we use are a smart algorithm. They are called, or smart kind of algorithm called conflict-free replicated data types, or short CRDTs. And those enable different users to edit everything at once from themselves, and then automatically, and most importantly deterministically, resolve any conflicts that might appear. To explain this, perhaps some of you have used a tool such as Git before to version your software projects, and sometimes two people have edited the same file, you get a merge conflict, and then you have to resolve it manually. And the difference here is now that on one hand this is resolved automatically, but it's also resolved in a way that is deterministic, so regardless what happens, what is edited, everybody who is using this thing and is resolving the conflict, they all get the same end result. So it's of course very important that the state of the whiteboard is consistent for everyone. It looks, the content, everything is the same for everyone, and that is the critical feature here. Yeah, we used YJS as a library to implement this CRDT, or well, it is a CRDT implementation, and we use it to build this whiteboard with it. It can even provide Delta updates, which we use for these real-time, on the real-time layer, on the WebRTC layer. And right now, this implementation is not reusable for anything else. So this is hard-coded in this project right now. But in the future, it might be possible to pull it out and also make it into a Matrix CRDT library if the need arises. So if you're interested in that, yeah, feel free to approach us. Yeah, so for example, the usual use cases might be to create a collaborative editor, and we might also look at these use cases if they arise from our clients. But right now, that's the status. So I've mentioned we have already overcome some big challenges. We have managed to achieve some backbone for this functionality. We are able to save our data inside of the matrix rooms. We have this conflict-free collaboration ability, and everything is communicated in real time thanks to this WebRTC layer on top of the usual matrix timeline event communication. And we had some additional problems that we have solved. So, for example, I think I already mentioned that events have a limited size in matrix of about 65 kilobytes or so. And when you consider some overhead, like the event has some additional metadata, you might use end-to-end encryption, and all of that, that results in 30 or so kilobytes that are actually usable by us to store our whiteboard data in. And I'll show you on the next slide how we solve this. There's also some more, like, for example, how to even read all the events from the rooms through the widget API, so we have to extend the widget API, or how to efficiently search for these whiteboard contents in an encrypted room specifically, where the server doesn't know what's what. And yes, I will get into that. But also some unsolved issues remain right now, which, for example, is history visibility is one of them. So you might know if you manage a matrix room, then you can set the history visibility. So, for example, you can prohibit people from reading any history that happened before they joined the room or before they got invited and so on. And the issue with that is they wouldn't be able to see what happened or that there is even a whiteboard in the room. Like I mentioned, there's this rate limiting issue that we can only send about one event or one update per 10 seconds, and the snapshot can have multiple chunks if the whiteboard is big due to this 30 kilobytes limit we have right now. And while so far we could, in theory, control the servers of our customers, we want it to be really nice and compatible for everyone and the default configuration. So we have to deal with the rate limiting. And also, well, if you do enable the invisible events or the hidden events, then you notice there are a lot of them. Of course, every edit more or less results in a bunch of those events. And now if you would be on the go and you load up your mobile matrix client on your phone, and well, everything that happened in the last 2 weeks is people editing on the Neo board, but what you want to do is read chat messages, then it needs to read all this history and download all the Neo board messages until finally it finds some text messages before that it can actually display to you. So it would be nice to have some filtering abilities for this. So yeah, let me get into these other challenges we were able to solve. If I can find my cursor again, there it is. So this is how we structure our events to store the whiteboard. When you want to, well, the issue is how to make these events available so that a whiteboard can instantly find them and you can read them from the widget very nicely. And one issue is, well, they might be anywhere in the timeline. It's hard to find a specific event if you don't know the exact event ID. And the trick we use for this is, well, we have persistent state events. They are always easy to access. And they are easy to get from the server. You just tell them, well, I need this type, I need this state key perhaps, and you get them returned. And then on the other hand, there are timeline events, and like I said, they can be anywhere in the timeline. You need to have the exact ID to find the right one. And so the trick is to use something called relations. It's a similar mechanism or the same mechanism that is used if you send a reply. Then your reply relates to the original message. And similarly here, what happens is we use on the very top, the green one is a state event. It's always there, and that saves where the whiteboard event is stored in the timeline. It knows its event ID. And then we have the existence of the whiteboard data itself. This is the next event, this whiteboard document create. And each whiteboard has exactly one of those. And then we have the snapshots, which represent the state of the whiteboard at a given time. And each snapshot can can have multiple chunks of data associated with it if the data is larger than 30 kilobytes. So if you edit the whiteboard, at first you would need to create, or the create whiteboard event gets created. And then you create the state event, which points to the whiteboard start. Then you write your snapshot, which relates to the whiteboard event. And then you start to write your actual data into these chunks relating to the snapshot. And then if you want to look it up, you do the lookup the other way around, basically from top to bottom. As it turns out, Matrix is a bit designed towards this messaging use case where the most relevant is always the newest stuff in the timeline, but there are ways to work around that if you think about it hard enough. Some other things we solved, like I said, we had to contribute a bit to the widget API, and one of these things was the ability to read these event relations through the widget API in the first place. And so there's this MSC associated with that, which was implemented in, which we implemented in the widget API. And right now, something ongoing is the ability to be able to upload files from the widget API. So you might have noticed that there aren't any images in this presentation. The most we have are emoji right now, and this is due to this limitation. We can't upload images as of yet. This is in progress, and once this passes, we would also be able to add images to this. And this could also be one solution to this issue we have of where to store all this data quickly, because we might be able to upload the actual state and all the whiteboard contents to the media repo instead of having to post all of these chunk events to the timeline, which again, it alleviates the problem of the rate limiting and so on. That would be very helpful. And yes, I hope everybody knows what MSCs are. Perhaps you have seen people with these MSC shirts around. And right now, I think we have also heard in the previous talk already, the widget API is mostly defined by MSCs, so not quite stable yet. And if you want to learn more about this, you can also check out the talk I gave with a colleague at FOSDEM this year. There will be a link to that later. So what is next for the Neo board? I already mentioned uploading images would be pretty nice to have. And yes, we have started the work on this. It's currently ongoing. And it would be nice to have some improved rights and role in order to control who can edit what, and perhaps only a few people can edit during a presentation. Right now it's limited to only the one presenting that can block others from editing the whiteboard while it's in presentation mode. And then right now, for example, editing the whiteboard, because it's all certain event types, you can either enable being able to edit the event types or not, but that's not very fine-grained. Of course, it might also be nice to have a standalone mode, similar to element call. You just share a link, so people hop onto the whiteboard, are able to work with it, and yeah, basically some kind of ad hoc solution. And then also, I already kind of mentioned this before, using the content repository for snapshot storage, that's tightly related to being able to upload images. That's the storing the whiteboard as well, instead of posting the chunks. If you play around with this a bit, you might run into the current limits of the formatting options, so it would be nice. While I can do some formatting right now, you might have noticed I haven't used any italics or bold text. So there are some options to improve there as well. Generally, we take care that everything we develop, and frankly, it's a requirement by the customers because we develop for governmental institutions, to have proper accessibility. Right now, the slides of the NeoBoards themselves are not accessible yet. And finally, it would be very nice to have also mobile support, so I don't need to tell you to get out your laptops at the start of a presentation, but you can just use your phones. Finally, of course, we hope real humans use this tool for really nice things. And so we are happy to get some feedback. But before that, I just want to give you all this additional info and links. So I mentioned in the beginning, I work at a company called Nordec. We developed this software and we developed some more widgets. Please approach us if you're interested. You can find most of them on github.com/Nordec, in particular the matrix/NeoBoard. If you read the README of that, then you will find there is even a demo deployment, or of course you can always self-host it if you like. You can use it for yourself in your own rooms. And inside of that repository, you will also find our architecture documents, architecture decision records. In the docs folder, you can learn more about how all these events interact with each other, how we overcame these challenges to be able to store whiteboard data and get it for some use case of this kind. There's also the aforementioned FOSDEM talk. You can find it in the FOSDEM video archive. And finally, if you are interested to join Nordec, then you can have a look at our website for any open job positions, of course. And now finally, it's time for feedback. Of course, I'm open to questions. You may also use this feedback slide. I will enable editing for you. And have fun. And yes, that's it. Okay. Do I have a microservice?
Yes, you will get one.
Thank you.
Who was first? Yeah. I start you this.
Just a very quick question. I was curious what the add widget command was to quickly add it to any room. Or is it even hosted in a way so I can just add it to any room, like the NeoBoard?
The demo deployment you can add to any room if you like, using this add widget command. And then basically it won't do the complete setup. It just tells it, hey, the widget's there. But the widget will detect it and it will tell you, hey, please press this button so I can fix myself. And after that, you reload the room, you have the whole widget in your room installed, ready to go.
Who else?
Thank you for your talk. I have a question to this m.relates to thing, because it looks like your data structure is a tree, not a generally directed acyclic graph. So when you merge state, you won't have one event that relates to two parent events. Is that right? Did you understand what I mean?
I guess I did.
It looks like
the widget API. Let me try and go back here. So what happens is first you have only one of these whiteboard events, and then when you edit, you have this snapshot events. They get put in a list of this create event, basically. So the create event knows which of these snapshot is the most current one, and really all the older ones are irrelevant for you because the snapshots are complete. And then again, the snapshot just has saved its data in a fancy way. And there isn't really any DAG merging going on as far as matrix goes, I believe.
I mean, the matrix event graph allows that an event has two parents. Because you receive an event from another home server, for example, and then the next event will reference both older events to say, I noticed both events happened, and this one is newer than both. And this doesn't allow that, right? Do you think it would be an advantage to have this possibility to list several parent events? would it help with state resolution or conflict resolution for your CRDTs or so?
I'm not entirely sure. It's probably irrelevant because this part gets handled by the CRDT level of things, but I can't be entirely sure at this point.
Okay, thanks.
More questions? There's one.
Regarding saving everything every time, 5 to 10 seconds, I'm not sure if probably the API can't do that, but maybe having a flow that somehow detects, okay, right now the last person is working on it, or after already closing the widget, we then trigger that to save the current state to the event. So you only save it like, okay, they stop working on it because we are WebRTC, it's replicated all the time.
Mm.
And the second it stops being edited, then it gets saved to the database or to Synapse as an event.
Right. I guess it's in the end a matter of making it work with Matrix itself as well as a backup. So yeah, I'm
Maybe there's a block. I just wanted to ask myself if there's a way to get around this in this way. But
yeah, it's a good proposition on first sight. I'm not sure what exactly the reason is, because I was not involved in that decision in particular. But I guess there's a proper reason that we do it this way. But I guess I'm afraid I can't tell. You might ask in the chat room, and somebody else might be able to answer this who isn't here today.
All right, thank you.
Thanks a lot. Any more questions? Would be time for one. But if there's nothing, then thank you.
Thank you.
Hello. All right. So that was the talks for today. Thank you again, Kim, for the last talk. There's going to be some slight evening program, so I want to just give you information, a heads up of that. We're going to get pizza sometime in the next hour. It's going to be over there. So that's also in the house. So thank you to our sponsors again. And afterwards, about 7:30-ish, we offer to join us for a pub quiz on Matrix, if you like. If you don't know the format of pub quiz, you come together as a team, so you need a team name and at least 2 people, but less than 10. We gather around here, we have some questions for you. You get multiple choice answers, it's not that hard. And whoever gets the most answers right is the most metrics of the matrices. We don't have a prize, but you get bragging rights. That's pretty awesome. So yeah, that's it for today. Have a nice evening. Oh yeah, get your t-shirts. If you ordered t-shirts, please get your t-shirts over there. We don't want to keep carrying them around. Ideally now. So get up and get them. All right, thank you.